All right. Well, good morning, Tulare. We will get started. I'm Walt Duflock, the Vice President of Innovation for Western Growers. Good morning to all of those in Tulare with me in our nice, warm building. It's a little different trip to the Tulare Ag Expo than we've had in previous years, and it's a little smaller crowd, but we're really happy to be here. A couple of housekeeping items to start. Restrooms on the left for those that need them. We've got a couple tables throughout the building if folks need to check email or do other things. We understand that. The world doesn't stop because you're at our show, so feel free to break away for an email check. Phone calls outside, please, and all phones off. Our hashtag for today, for those of you that are social media-ites, is hashtag WG Innovation. So if you're posting, we'd appreciate you using that. And today's event includes both a live component, you folks in the audience here, and a virtual component. We've got a live stream going on YouTube right now that folks are watching. So thank you to those that are joining us from outside the building. Almost 2 years ago, in May of 2019, this project was launched at Western Grower headquarters in Irvine with grower members, technology companies, manufacturers, and researchers. Today, the outcome of all of that work over almost 2 years is the launch of the Global Harvest Automation Initiative to help address the growing challenges related to food security and harvest labor. These are among the biggest challenges facing WGA members today. Every year, fields are prepped, seeds are planted, crops are irrigated, thinned, and weeded, and monitored for pests and foreign objects. And after all of that effort, some of these fields are unable to be harvested because there's no available harvest labor. At the same time, regulatory costs from overtime, wage changes, and heat rules are driving the cost of the available harvest labor up. Some of our larger growers estimate that labor costs will increase by up to 70% in the next 5 years. So both of these forces, unharvested crops and huge cost increases, are combining to make the need for harvest automation more urgent than ever. Today we'll hear from a global set of Western grower partners about this initiative. We'll hear from AgTech partners and startups from the UK, France, New Zealand, Australia, and Israel. We've developed and continue to develop global partnerships for two main reasons. First, this is a global problem that challenges growers everywhere. Second, there are a global set of solutions that are getting developed everywhere. Partnering with global organizations helps bring the world's farmers and innovators to the same table and is the best way for WGA to lead this global initiative. Dave Puglia, the president and CEO of WGA, will give his perspective today on why this initiative is such a big bet for WGA and our members. I don't want to steal Dave's thunder, but WGA is making a big public commitment to this initiative today. The Washington Tree Fruit Research Commission will give their perspectives on the importance of this initiative for their members and will be signing an MOU with a 3-year commitment. Wilfred Albert from Roland Berger will give an analyst perspective on this initiative as it relates to other automation in other industries. Some good perspective for us. Then after a lunch break and some really good tacos, and we did test the tacos for you locally, you're welcome, we'll focus on one key component of the initiative, the technology stack. Trimble and Microsoft will provide some context for how this initiative creates opportunities for their companies to participate in solving the food security challenge for growers. We'll then have a technology panel discussion about how this initiative can impact the technology companies and how they can help support the initiative. This will be followed by a grower panel discussing the importance of the initiative from the grower's side, particularly specialty crop growers that are some of the largest growers and use a significant amount of harvest labor for their operations. Finally, we'll close out the day with presentations from AgTech New Zealand and some of the startups from the New Zealand region. Before we dive into the agenda, I want to give everyone a quick overview of the 4 key components of the initiative we're launching today. First, the technology stack. We'll cover this in more detail later in the afternoon session, but think of it this way. Currently, harvest startups build the entire technology stack themselves, from imaging to artificial intelligence to interpreting the images and determining what's food and what's weeds, and what's ready to harvest versus what's not ready to harvest. To robot arms, to end effectors that actually harvest the crops, to tractors to move everything through the field. This is why, even with tens of millions of dollars in investment and years of development effort in startups for strawberry and other harvest, we are still harvesting a very low percentage of fruits and vegetables by robot. The technology stack will help startups integrate with industry-standard tractors, robot arms, sensors, and others to help commoditize up to 60 to 80% of the startup's technology stack. The implementation of the technology stack and systems integration resources that are equally important to help startups will be one of the key accelerators for the startups. We believe that this can save startups quarters to years of development time with proper implementation. The second big component is picking a cohort of startups to work with on this initiative. The cohort will be selected and will get extra time and investment from us to help accelerate their efforts. Grower and partner evaluations will be used to pick this cohort, and we'll work with them on systems integration, mentoring, and case studies to help maximize the impact of harvest automation. The systems integration piece is really key. This is not an if you build it, they will come. This is if you build it and help them, they will come. And we know that, and we're planning on that, and we're resourcing for that. The mentoring will also focus on economics that work for startups and growers and on go-to-market strategies that leverage the channel partners such as equipment dealers and labor contractors. WGA plans on staying intimately involved with these startups and with their members to do both field trials and case studies. The case studies will be written and published by Western growers so that all of our members get the benefit of the case study. This is a big change from our current approach of introducing startups to farmers and then letting them handle the rest of the transaction themselves. Western growers is now going to stay involved because everyone realizes there's a lot of benefit to publishing those case studies and getting the leverage across multiple growers. The cohort will start with a small set of startups, probably 3 to 5 that we get good feedback on and can provide resources to support. As we get more feedback and identify more startups that are worth supporting, we will add more startups and provide them with both the systems integration, case study, and mentoring support from our members that they need and want. It's worth mentioning that AgTech is having a big impact on farm labor, and as we get more AgTech solutions into the fields, there will be a need for farm labor to evolve so that it's able to work effectively with the robots, understand how to improve them, and service them. If we look historically at thinning as an example, which has done well to get into the marketplace, thinning didn't remove the 25-person thinning crew when you implemented the thinning machine. Thinning actually changed that 25-person crew to a 3 to 5-person crew that's higher skilled, higher cost, and harder to find. And one of the things Western Growers is working on in conjunction with this AgTech push is to help build that next generation workforce that we're going to need to take care of and look after all the robots. The tech stack and the cohort are meant to provide the resources needed to help the startups get to scale. The last 2 components of the initiative are to help growers. The first component's the roadmap. The roadmap's going to help identify startups that are getting to scale by crop type and shows each individual startup's position relative to other startup positions for that crop. We will publish the first roadmap this summer, then update it quarterly as we get new startups and update the traction portion with progress for each of the startups. This visual representation of who and what startups are working with which crops is going to be really useful for farmers to understand who the players are that they want to work with on their crop type. And we think it's going to be a really useful tool for startups who will obviously want to be on that roadmap and in the right place. So it should help both groups. I'm a big fan of market maps, particularly Shauna Day's work to develop what I believe is the most comprehensive market map of agri-food tech startups. They're great for their intended purpose, identifying startups that are in each of the agri-food tech segments. The key difference with our roadmap is to not just lay out the startups that are doing the work, but to actually show on a relative basis which ones are further along and do it by crop type. Our focus will make us different and I think more useful to farmers for this context. Harvest Roadmap will be the first roadmap that Western Growers releases over the summer, and we plan to build other roadmaps, such as food safety or crop-specific roadmaps. Imagine a food safety roadmap for detect and fix that shows the relative traction performance of solutions that can identify and fix challenges like E. coli and Listeria at each point in the supply chain, from field to truck to production to the store or restaurant. Consider how useful it could be for a spinach grower to have one roadmap with all the innovation options related to labor, including thinning, planting, harvesting, and weeding. Each roadmap will provide the same benefit to the growers and help them identify the startups they should look at and which are in market and at which stage. So we're excited to roll the initial roadmap out this summer, and more are coming. The fourth and final component is impact. This helps the industry quantify the impact of the harvest automation startups. Capturing the industry-wide impact is going to be a little tricky. Farmers and startups look at the impact of automation differently. My conversations to date have confirmed that, and our conversations with members have definitely helped us understand where we want to start thinking about this. So we'll have an annual report, the initial one of which launches this year, on where the baseline is for harvest automation, and each year we'll update on how are we doing. Let's hold ourselves accountable for making progress, and let's publicly state the progress that we're making. So those are the four key components of the Global Harvest Automation Initiative: a tech stack, a cohort of startups that are enabled with systems integration, mentoring, and case study support, a roadmap to identify the startups that are in market with traction, and an impact report that quantifies the annual impact of the aggregate set of harvest startup activity. All of this is supported by a global network that can help accelerate market entrance into multiple geographies for the startup cohort, and case studies that capture the actual benefits to the growers from field trials. Now I would like to introduce our first partner presentation. Dr. Belinda Clark is a director of AgTech E and joining us virtually from Cambridge today. AgTech E signed an MOU with the WGA last quarter to collaborate on AgTech generally and this initiative specifically. WGA collaborations with global partners like AgTech E will help ensure that startups in all regions have easier access to other markets for field tests and starting to scale beyond their initial geography. Belinda, thank you for joining us and giving us an overview of AgTech E and the importance of our partnership and this initiative.
Thank you so much, Walt, and good morning, everybody. I very much wish I was with you in person over there today. It's a rather dull, miserable evening in Cambridgeshire in the Fens in the UK. Highly productive agricultural land, lots of vegetable production, lots of arable production, but we're not going to have tacos at lunchtime, and I wish I was there to hear your stories, to learn about your experiences, and to share some of ours. However, through the power of technology, what I'd like to do is to give you a little introduction to AgTech E, to explain why we're very excited to be partnering with the Western Growers Association in this important initiative. And then I'd like to introduce you to some of the robotics capabilities in the UK, some of it quite early stage and at the research end, some of it closer to market, to just give you a little flavour, by no means comprehensive, but just a little flavour and interest about what we have in the UK. So if I may have my first slide, please move on. Okay, so what I'd like to do is just introduce AgTech E. So we are a membership organisation, we're independent, we're not funded by government, and what we're about really is catalysing this multidisciplinary approach to just moving the needle around agritech. So we know that chemistry and breeding and machinery are going to be crucial to the future of the industry, but also we want to bring in technologies and expertise from other sectors, from earth observation, from artificial intelligence, from machine learning, and really providing a welcoming place for these new sectors, new experience to come in to the industry and to contribute to a tech stack. So we're independent, we have an ambition to be this global catalyst for open innovation. I won't read all the lists there, you can see our ambition and what we do, and this whole piece about multidisciplinarity I hope will come out through my talk. So if I might have the next slide, please. So this shows a very rudimentary, if I could ask one click, please, thank you. This shows a very rudimentary value chain, and we could argue for the rest of the afternoon, I'm sure, about the lack of linearity and the way the value chain works. But if I could ask just to run the animation to just show you an example of some of the members that we have in our network around each of those different places on the value chain. And I illustrate this, as I say, it's not comprehensive, but to demonstrate the kind of innovation ecosystem that we've pulled together, and the two cohorts that I'd particularly like to draw your attention to, as well as the farmers and growers up there above producers, and the top left-hand side, the research. So that fundamental and discovery moving through to the applied on-farm research. That's really the engine, the engine of the innovation that is leading to inspiring some of the startups. And I know there's some startups here who have spun out from the research base in the UK who are at the event this morning, I'm afraid. The other group I'd like to draw your attention to is the bottom right-hand side under the sort of networks and funders and enablers. And among those is the UK's innovation agency, Innovate UK, who are members of ours. And they, in the last couple of days, have announced a £12 million fund to help facilitate academic and industry collaboration to accelerate new technologies to help transform the food system. So that's just a little flavour of the kind of membership we have. Now, the next slide shows just some examples of the sorts of things we do. We run events, which are, of course, online now, so you're all very welcome to join. You don't have to be a member to join, but you will have to pay if you're not a member. So really just taking a dive into all these different topics. You can see up there one example that might be of interest to this audience is swarm robotics. So we looked at how you could actually link the robots together in a kind of master-slave relationship so that you can actually increase efficiency. So just taking a dive into those topics and bringing together the farmers and growers. And the next slide just reminds us all that actually geography is no limit to being involved. We write reports from all our events, and our members have access to all the outputs and reports from all the events that we run. Now, one program that we do is illustrated on our next slide, is a program called AgTech Week. And this is an initiative that we run in the autumn, in November, in the UK, to try and just celebrate the excellence and the vibrancy of the AgTech community in the UK. And this is just an example of some of the events we had during AgTech Week 2020. Obviously, they were all digital, but you can see a kind of smorgasbord of topics and ideas which hopefully will resonate with both the farmers and the researchers and technology developers. Now, in the middle of AgTech Week, we have our REAP conference, and the next slide shows the logo, hopefully gives you an indication of the topic that we were looking at, which is how you can connect up what's happening in a micro level, either microbial activity in the soil or even the molecular things that are going on in plants, and how that moves up through all the tiers of the farm system, through the field, the farm, the catchment area, and how the technology can enable one to move up and down those different layers of the agri-food system. And it was at REAP, we were very proud to announce the relationship with the Western Growers Association. And then a couple of weeks later, you can see there on the slide that Walt and Dennis and my colleague Alex Dinsdale and I signed the piece of paper to really cement the relationship. And building on that, we held an event a couple of weeks ago, which showcased some of your fantastic growers over there in the Western Growers Association, really articulating very elegantly some of the challenges that you face in terms of the automated harvest and the kind of wish list that you have that then the technology companies in the UK then really got that first-hand insight into what the challenges are and what you're looking at, the solutions that you're looking for. So let's talk a little bit about some of the technology. Let me introduce you to some of the robotics expertise in the UK. So the next slide introduces you to a program that was really developed as a demonstrator. If you could just run all the slides, all the animations on that slide, please, that would be helpful. And this is called the hands-free hectare. Now, this slide is a little bit old because they have now built that into the hands-free farm. And this started at Harper Adams University, which is one of the leading agricultural-focused universities in the UK. And the ambition, as you can see from the slide, was to grow a field of wheat that had no human intervention in there at all, from drilling to harvest. And you can see, again, these data are a little bit old. You can see the yields were actually pretty respectable. And now the idea is to tech up a whole farm so that we have this autonomous approach to demonstrate what is feasible and possible. And you can see the machine there is not state of the art, but it's loaded up with some of the state of the art technologies to be able to demonstrate the feasibility of this project. So the next slide moves us on into harvesting. So if we can run all the images on that slide. So first of all, to introduce you to the University of Cambridge, and the Department for Engineering has been working very closely with one of the UK's major salad producers, Gee's, and they've been looking at automated lettuce harvesting. So you can see some of the images there about that. But the department is also looking at soft robotics. So it's not just emulating the existing maneuvers that a human hand would do, but it's also looking at alternatives. Could we, as some of your growers said at our event a couple of weeks ago, really just change the way we even think about growing and harvesting these crops? It doesn't have to be based on the system that we know, because we have human hands to do what they do. And then in the top right-hand corner, introduce you to dog-tooth robotics, which I think is known to some people in the Western Growers Association. That picture was taken at our REAP conference a few years ago, and the robot actually rather spectacularly came into the conference lecture theatre and trundled down the stairs to the stage and took a bow on the stage. And that's now really, it's out on farms, strawberry farms. And then the other image is from the University of Essex, who are working with Tiptree, which is one of the major producers of jams and preserves. So they have a huge interest in efficient soft fruit harvesting. And I'll show you a video on that in a moment. So let's go outside into the field with the next slide, please. And I'd like to take you to the University of Lincoln, which is fast establishing a leading reputation in agricultural robotics. The British government has actually given a very significant investment to the Lincoln Institute of Agricultural Technologies around training, around PhD opportunities, to both develop the research skills, but also to develop the technologies around agricultural robotics. And you can see here some technology that's being developed around automated broccoli harvesting, using the machine learning and the AI and the visualization to be able to ascertain when the broccoli head is at the right stage for harvest, and passing over those that are little immature, thus reducing wastage. So this is all nice having these pictures. Let's have a look at them in real life. So I think my next slide has a video on it. So if I can ask if we could move on to the next slide and play the video, please. So this video shows some examples of the kinds of technologies that are now being used out in the field, not just to actually manipulate and harvest the crop, but also to act as a bit of a kind of workhorse, if you like, to be able to move product around. You can see there the University of Essex robotic strawberry harvesting. This is the hands-free Hector on its maiden voyage at the UK's leading arable trade show. I hope I don't need to point out that the video has been speeded up. It's not quite that efficient. It is efficient, but not that efficient. And then there's just some examples that the video will run through of field phenotyping, of monitoring, of being able to move product around, to be able to, in an automated way, establish growth stages and report back and collect the data. So the other point to make is that certainly our fields outside at the moment are looking pretty rough. They're frozen solid and they're muddy, and it's a very challenging growing environment out there. I know you've had some challenging weather in California as well, but the ability for these robots to really work outside efficiently is something that people are working pretty hard on here in the UK. So if I could move to my next and penultimate slide, please. I just wanted to leave you with the reassurance that the UK government, not that I can speak on behalf of the UK government, absolutely not, we're not government funded, but we do work closely with colleagues in government. And this is a picture of an event that we hosted for our members at the House of Lords in London a couple of years ago. We launched a report about agricultural technologies. And the gentleman on the podium is George Freeman, who is an MP. And he was very involved in 2013 in the development and launch of a national strategy for agricultural technologies in the UK. And that had, I think it was £160 million of new funding to help with academic industry collaborations, with new collaborative R&D, with training. And we're now at the end of that initial cohort of the strategy, but it was deemed very successful. And we're now really reaping the benefits of that very enabling political environment in terms of both funding and skills development, and I should say regulation, which I don't have time to talk about here. The other picture, the gentleman in the picture with the river behind them, just to point out the man next to me, so there's George Freeman, then myself. The man next to me is Lord Sainsbury, who was a former Minister of Science in the UK Parliament. And the gentleman on the end next to him is John Shropshire, who is the Chief Executive of G's Fresh, who is, as I said, one of the largest salad producers in the UK. Very forward-thinking, very willing and keen to embrace technologies, I know, as are your growers. So if I could just move on to my final slide to leave you with our contact details. Please do get in touch with us. We have members all over the world, so we'd be delighted to talk to you. But more importantly, I think, to really just reinforce how pleased we are that we have this relationship with the Western Growers Association. Hearing Walt's introduction really just illustrated how we are seeing the same issues, the same challenges, the labour issue. I didn't really want to say the B word, but I will say Brexit. The UK has left the EU, where a lot of the migrant labour came from, the seasonal labour for harvest. So this is a very live issue for us as well, and we very much look forward to working with you when it comes to finding some technological solutions. So the future is very exciting, and we look forward to being part of it with you. Thank you very much for your attention.
That's great. Thank you, Belinda. Some great UK perspective on this initiative. And next we'll move over to France with FIRA, the French International Robotics Association. We've got Milan and Gwendolyn joining us. Hello to France.
Can you hear? Good?
Yes, we can.
Okay, great. Well, waiting.
I'm sorry, I'm afraid my camera is not working well.
Yeah, virtual issues.
No matter.
Yeah. Well, maybe we can start presenting, waiting for our presentation. Gwendoline can start.
Yes, sorry for my camera that's not working. That's yeah, technical issue. I'm Gwendoline Legrand. I'm the co-director of GoFar, the non-profit organization that is organizing FIRA, the International Forum for Agricultural Robotics.
Hi, everybody. I'm Mayelen Cazenave, the co-director, the second co-director of GoFar, and we are very happy to be with you today from France. And thank you to Western Growers for the invitation. So we will start talking about our non-profit organization and then to present our action. So please, next slide. And the second one. Okay, so GoFar is the global organization for agricultural robotics, is the cornerstone association for promotion of agricultural robotics. So we launched the organization two years ago, but our action started 5 years ago now, but the official organization was created in 2019. So GoFar mission is to promote and to develop the agricultural robotics sector at an international level. Not only we are based in France, but our actions are definitely worldwide. So GoFar meets the increasing needs for visibility and networking of the agricultural robotics sector. So the organization aims to organize the meeting between the relevant stakeholders of the industry. We are working with all the key players of the value chain of the agricultural robotics industry. So our action are addressing to farmers, but also we are working with robot manufacturer, with technologies suppliers, with university and research, with also agri-furniture and agricultural machinism. So we are supporting all the key players of the value chain by taking an active part in the development of the market, and by implementing a promotional campaign of international scales. Please, the next slide. So we are different action in GoFar every year. So first, FIRA, which is the main international forum of agricultural robotics. This is an international event for the industry. We will come back later. We launched last year a web media called Agricultural Robotics News. So it's a free online media with dedicated to the industry, with a monthly newsletter. So you can find different category in this media. So we talk about the market, about robotics, about research, about the new technology, and it's dedicated to the industry. And in our action, we are also developing international collaboration. So it can be with major international events such as the SEMA in France or Agri Week in Tokyo, for example. AgroMech in Denmark. We are also working with major media in Europe, for example, with Future Farming. In the US, we are working with Meister Media and also WWH Media with the Robo Business Direct, for example. And we are also developing strong collaboration with major organizations, such as here for the US with Western Growers, but also in Brazil with ABIMAC, and with different organizations, we can help us to spread and to promote and to develop the agricultural robotics industry, because we cannot we need to collaborate and to create an international worldwide to help the development of the industry. So here it's an overview of our nonprofit organization, but please take now time to talk about the major event, of course, of the industry, the FIRA. So please, next slide.
Yeah, thank you very much, Mayalen. So yes, indeed, FIRA, the International Forum of Agricultural Robotics. We are going to present you the history of the event on the next slide, please. On the next slide, you will see that FIRA is not a new event. Maybe you've already heard about it, or maybe not, but it has been launched in 2016. So we are about to organize the 6th edition this year. As you can see, the key figures, the event has been growing very fast. It has been launched and we were around 200 people, maybe mainly coming from Europe, as the event takes place physically in France. But year after year, we have seen the increased interest of the industry to be all together and to build this new industry all together. This is the aim, the main goal of FIRA is to gather the key players of all the value chain, from the manufacturer to the producers and the farmers, of course, but also with the technology suppliers, the research, and all the value chain. So This is why I think FIRA is really developing that fast. In the, last year, it was in December 2020. Of course, we had to make a big choice. From the beginning of the organization of FIRA 2020, we said that it was going to be virtual. So we didn't want to be a plan B for FIRA 2020 in this virtual edition. And we took this opportunity as a big opportunity to develop the event internationally. And we think that the success was here, as we could gather, and we are going to gather again and again new participants. 3,000 attendees are going to join FIRA, as FIRA stays open until June 2021. So this is an invitation. Please come and register. You can still have a look around at FIRA contents and partners. You can also have a look at the robot manufacturers that presented their innovation. This is very important. FIRA is the place to be when it comes to have a look, an overview of all the main manufacturer of agricultural robots. You can have a look at the demos that the manufacturers presented. You can also listen to their pitches. And it's very, very interesting to see how many functionalities and features manufacturers are co-developing with the producers. You can discover robots that are harvesting, picking. This is our subject today, but also about another main issue that is the weed control. So please have a look at FIRA again this year. It's online and you can find it. You will have a look at the website later. We can go to the next slide, please. Now let's talk about FIRA 21 that is going to take place in December this year from the 7th to the 9th. We are going to organize this year, hopefully, an hybrid version, both in person and in the virtual format on the same platform that we experienced last year. That is American 6Connex. It's a very, very impressive platform. The goal of FIRA again is to follow up the main evolution of the industry in terms of technologies, legacy, markets, and of course, new robots and the new entrants on the market. How FIRA is articulated? It's events based on contents, on sessions, on discussions. So we organize live sessions such as roundtables, keynotes, the scientific workshop with the non-profit RobAgri, the thematic workshops depending on the crops and on the features, and some pitches also. The exhibition hall is also developing a lot with robot manufacturers presenting their evolution, but also technology suppliers. In this edition 2021, we are going to reintroduce the B2B meetings and some informal way to do networking, which we think is very, very relevant for the industry. And again, demos of robots, and this time, hopefully, we're going to organize some in fields directly to see the robots in motion. So as I mentioned, you can still register for this year edition on FIRA-AgTech.com. We can move on the next slide. So Maya, please, if you want to introduce the...
Yes, yes, we see that we develop the FIRA for about 5 years now, and this event is definitely an international event because we can see that we gather even more the audience from the US, from Australia, etc., and also new partners coming from the different corners of the world. So we develop strong collaboration with media, with partners, with manufacturers in the US, and also with Western growers. We find a good way to collaborate and to continue our collaboration for this year. So we decided to launch a FIRA dedicated to the US market. So It won't be the same, of course, the major event that we have in December, but and it's still, the work is still in progress. We are still thinking about it, but we definitely want to start organizing FIRA in the different region of the world, you know, to be really focused on the needs of the market, because even if it's global, I think it's important, you know, to be local in the way we are doing our event, and we are presenting the robot, the needs, and the different issues of the industry. And it's also important for us, and we are working like this from the beginning, it's to build collaboration. We are not working alone. We are a non-profit organization. We are creating a worldwide ecosystem, but we want to collaborate, and it's the same for FIRA, it's the same for our action, and it will be the same for the US. So we are thinking, you know, about organizing a technical day, probably in November, and of course targeting for, you know, we are targeting producer and farmer, but also we want to work with robot manufacturers, technological suppliers, for a big day in California. Maybe you can complete, Gwen, with the content.
Yeah, exactly. So what we think is that the main point, and as Western Growers is promoting and experiencing this, we need to provide solutions. Okay, so we need to provide robots that are working and that are bringing innovative solutions to producers. So first of all, we need to organize some conferences, some keynotes, to explain a little bit more how robots can help on labor issues, on safety issues, etc. So it's very relevant for us to bring this content to the US in California, to better understand maybe from the producer side how it can be a huge help and a huge support for their everyday work. Then, and that will be the main part of FIRA USA, we are going to bring demos of robots in the fields, in different on different crops. That's very important. So we want to bring it for corn, for vineyards, for vegetables, for seeds. So really, it has to be full, and to we will have a very big chance to discover in one place so many robots in motion. And then we also want to promote the expertise and the skills of our partners through some corners in an exhibition zone.
And why California? It's because there is major robot manufacturer. So we can see now on the screen, there is FarmWise coming after us. Hi. And there is also Naya Technology from France in the US, and there is Gus, and there is other major robot manufacturer that we are already working with. So we think that it's time now, you know, to have this kind of event. So we totally are still creating this event. We totally want to work with partners and with organization in the US who want to take part of the ag revolution, we can say. So in the next slide, in the final slide, you have the contacts, our contacts, the FIRA website, our media website, our social network. We are very engaged, and you have also our email address if you want to learn more about FIRA, about the GoFar, and about, you know, the action we want to make in the US, and to collaborate with us. We are totally open for this kind of action. I think we've done.
Yeah, thank you very much, everyone. So yes, please don't hesitate to contact us to have an overview of how we could collaborate in promoting your expertise through FIRA.
Thank you very much. Have a very good day and a good pitch to to FarmWise and the others.
Yeah, good pitch.
Thank you.
Thank you very much. Bye.
Thank you. Bye.
That's
And thanks for the
great.
picture. Really appreciate it.
Thank you for the FIRA, the FIRA overview, Mylan and Gwendolyn. And if I hear right, Sebastian is already on. So we've heard from two industry groups from the UK and France about the need for global support and to really help these startups get into new markets. Let's hear it from the startups perspective for a moment with Sebastian from FarmWise. Sebastian, are you ready to launch?
I think so. Can you see my screen? Can you see the slide on the screen right now, Walt?
Yes.
Yes. All right. Great. Thank you, Walt. And glad to be here. Hi, everyone. So I'm Sebastian Boyer, co-founder and CEO of FarmWise. We're a US-based company. We're actually based in Salinas for most of us. And we started up in 2016, obviously realizing that farmers were in great need of help in automating some of the most tedious tasks in the field. And so very early on, the way we started the company was to partner with growers in Salinas and Santa Maria to really understand their problems and build with them solutions to these problems. And so we today are providing a robotic weeding service to vegetable growers in California and in Arizona. The team is about 60 people. On the engineering side, we have people that are coming from self-driving car industries, space industries, to help us build not only the best technology in terms of precision and data, but also turn these technologies into something that's truly made on the field. And so a lot of our engineers are coming from universities in California, such as UC Davis, Cal Poly, and so on. Fairly quickly about our approach. So what do we do? You can see behind me here one of our hubs where we from which all machines are being transported to the field every morning. So essentially what we do is that we built this machine last year, and we use this autonomous weeder to provide weeding services on the field, charging on a per acre basis. So the core of the technology here is to, first of all, identify weeds and crops. And I'll get into kind of how we do this and why this is relevant for more farming tasks as well. Then the second step is to, based on that information, move very precisely, but also very quickly, what we use to kill weeds, which are blades. So we move these blades in the ground. And then once you made the decision of when and where to move the blades, you have the hardware components, which are obviously key. And the flexibility and the precision of these hardware components is something that we put a lot of efforts into. So you can see on that picture our first generation of machine, the one that we built last year. And we've already weeded about over 100 million crops over the past 2 years. As we go through the field, and that is true for the weeding machine that we have today, as well as for other equipments that we're building for other processes, our machines are always capturing as much information as they can on every plant. And that information is really useful for our customers today. And you can see here some of their tools that we already have available. And we're obviously working with every one of our customers to iterate quickly on these features to create more and more value for them. So again, we perform a robotic weeding service on the field, and we use that service to capture and analyze data that is useful for the same farmers. We work on a variety of different crops already, which allow us to, for every single customer, to be able to work on many of their fields, which is sometimes very useful. And we recently we actually opened our shop, this one here, our shop in Salinas at the beginning of last year. And we're also in Arizona since October. So I wanted to give everyone this morning like a snapshot of why we believe that artificial intelligence is a key technology that is going to change the way agricultural machines are built, and why this is so useful for our industry, for the farming industry. So the way we see it is that one of the core difficulties for automating tasks in farming is the diversity of fields, and the fact that because you're not in a industrial plant where you control everything, you're in a natural environment, you have naturally a lot of things that are going to be very different from one field to the next, but also from one day to the next. So I mentioned here a couple of dimensions: soil, crop type, weather, stage, but there are many, many other dimensions. And software and robot really don't like this. They like things that are exactly the same all the time. And that's mainly why, up until very recently, we haven't seen a lot of technologies really breaking out in the industry and getting adopted widely, because it's very difficult to solve for all of that diversity. And you can see here example of what I mean by diversity. So this is the same crop. So it's not even here a question of different crop type, but everything else is very different. The light is different, the soil is different, the types of weeds, the number of weeds, the size of the weeds. And so that is the diversity that you need to deal with when you work on automation for the farming industry. And that's very hard. And that's why, again, classical software and technologies from 10 or 20 years ago really didn't manage to solve for that diversity, to solve all of these issues. And that's exactly where AI comes in, or artificial intelligence comes in. The power of artificial intelligence is to be able to use data from all of these different fields and kind of figure out not like one rule or one algorithm per field type, but really like one general way to understand what a field is and what you want that machine to do. So very similar to how the human brain works, where we can kind of see patterns that are much more high level than the details of the pixels. An artificial intelligence algorithm is going to be able to understand all of that diversity and provides the service provider or the technology provider with a simple way to solve for that diversity. So that really is the reason, in our opinion, why AI is so important for the farming industry. And you can see here the results. Like, this is one algorithm. This is not one algorithm per field or here per image. This is really one algorithm for all of these images. And so the same AI was capable of understanding what a crop really means in the context of all of these different fields. And that's really key to building solutions that really scale and that are robust to every field. So that is really the promise that we at FarmWise are on a journey to leverage. And our goal is to leverage these technologies to solve real problems for farmers today and to help them with the issues that they have on the field on a daily basis, help them augment the productivity of workers, and help them reduce cost and increase yield in different dimensions as well. So our thoughts on in terms of harvesting challenges, because that's obviously the theme, one of the themes of today. We obviously believe that the very similar technologies are going to be at stake here. You need to understand where crops are, localize them in space, and then have a physical system that is capable of quickly and really precisely acting on these crops. So from that point of view, these technologies are going to be very similar to the technologies that we are today using to solve weeding automation. We also believe that there are differences. The first, more players, and then longer timeline, and that comes from the fact that obviously the precision that you need and the dexterity of the human hand when doing harvesting is much greater than the precision and the dexterity of a hoe that is used to do weeding. You have all of these different fingers that a hoe doesn't really have. And so that where the differences come from. So when we think about these different processes, and when we think about harvesting in particular, our approach is the following. We believe in like two things. One, the necessity to break down the process in smaller chunks. Harvesting is this kind of big word for a process, but it's actually multiple processes happening one after the other that are very different from a mechanical and technology point of view. And so we believe that one need to break down harvesting into smaller chunks in order to start really creating value on that process. And then obviously, because the timelines are getting the timelines are getting longer and the overall complexity is higher, we're big believer in reusing and partnering with, so reusing technologies and partnering with existing companies to try to not reinvent the wheel too much. And so obviously we think that there need to be like a strong system integrator, but that individual technologies can be leveraged from different partners. And that's why we've been excited to follow the WGA's efforts on building that consortium, so these players can really talk to each other as often as possible. Thank you.
Sebastian, thank you. That's a great overview from the startup perspective. And now we want to hear from the investor perspective. So how do the people that finance these startups and plan on the global expansion view the world? And for that, we've got a great presenter. Arama Kukatai is here. He's the partner from Finisterre Ventures. They are a major AgTech investor, as all of you know. And it'll be great to get Arama's perspective. Arama, are you on?
Hey, good morning, Walt. I am indeed. Thank you very much. Here we go. I think I managed to get the video going. Just checking that you can hear me okay. And I'm also being joined by my colleague Gil Miron. I'm here in San Francisco today, and Gil's calling in from New Zealand, actually. So we're spanning a few different time zones here.
Good morning, everyone.
Good morning, and we can hear you great.
So, Walt, thank you for the kind invitation to myself and the Finisterre team here to attend. I just want to acknowledge the great work that Western Growers has done and is continuing to do in helping build the technology and innovation ecosystem, particularly in relation to automation, the other topic that has brought everybody here together today. As you mentioned, I'm one of the partners at Finisterre Ventures. We're a specialist agri-food venture capital fund and have been investing for the last 15 years in ag and food related technologies. So today's discussion, I think you'd asked me to come and really provide some commentary and overview, particularly in relation to our activity in Israel. And you might ask, actually, what is somebody with an accent that's not a US accent, but not an Israeli one either, talking about Israeli technology? And in part, it's because Finisterre's approach to innovation investing has spanned beyond the US and particularly has been focused on activity in Israel. Gil, on the call here, has been one of our partners in the Israeli market for the last 5 years. I'll ask him to say a few words and just provide some background and thoughts about the evolution of the agri-tech space in Israel. I know we have a number of companies presenting today too out of Israel, but perhaps just to make a couple of comments as an overview. It's now just over 20 years since I first went to Israel, actually in relation to the farming enterprise that I was one of the founders of, looking for new technology to help us actually with pastoral farming and dairy all the way on the other side of the world in New Zealand. And why? Well, really because Israel, as it's often known, the startup nation, has really been one of the world's key centers of excellence in research and development through to applied commercialization in many, many fields. But in particular, and of particular note, in the last decade, in agriculture. And really led by, I think, quite a unique ecosystem of research institutions, of the highly educated technology workforce, but also an entrepreneurial spirit that sees, this small country of 8 million people pointing out to the world and looking for opportunities to take their ideas, their innovation, and their technologies to a broader audience, really every corner of the planet, but particularly into the United States, where, of course, Israel enjoys a very special relationship at a country level. But at the industry level, we've seen more than 450 startups in the agri-food space, a pretty staggering number given the size of the country. And in the last 2 years alone, more than $400 million of investment that has flowed into the AgTech sector, including into companies that are focused on harvest automation, crop solution products, agro-analytics, all of which I think are of interest to the audience and to the group today. Philister ourselves have made several investments, more at the analytics end, so we're investors in a company called CropX in the sensing irrigation recommendation space, and a company called Tyrannus, one of the pioneers and leaders of high-resolution digital imagery. But again, we've also evaluated a lot of companies that are coming through in the robotics and automation space, which as you get closer and closer to the farm and have a higher hardware component, I think these are companies that become particularly relevant to the mission and the work, Walt, that you and Dennis Donahue and others of the WGA group are focused on with both today's session, but also in some of the projects you proposed and we'll be discussing today. Hardware is challenging, right? It probably is no surprise to anybody on this conference today. Challenging in a lot of ways, including getting past early prototype development and into commercial scale-up and commercialization. And it's important that we get the opportunity with young technology companies to be able to test and trial their products and concepts with real users, with farmers and growers who know what they're about and know what they're looking for in terms of both a practical solution and a return on their investment. And one of the early conversations that myself and Jennifer Place, I think is also on this call from Finisterre, had with Dennis was around the range and diversity of solutions that the Western Growers Group and members need across, at the time we were talking, I think as many as 20 different crops. And so that poses an additional layer of challenge. How do you adapt solutions so they are capable of covering a pretty broad range of specific crop types and still do so in a way that it's going to be both economic and commercially scalable for both the technology partners as well as for the growers? I think this remains a significant challenge, but I think one which your proposed approach here today, looking at ways, for example, to bring field trials to life. How do you start to scale and drive adoption? And frankly, including a feedback loop to the technology startups so that this is not just technology push, but that solutions are being developed and provided that really meet pressing and appropriate concerns and addressable concerns of the farmers and growers. Companies that are on the line here today, like Tevel, FFR, and there are many others coming actually out of Israel that are really highly well-funded, but highly intelligent solutions to the challenges facing us in farming, I think are going to be at the forefront of finding adoption and maturity of hardware solutions and automation, and particularly in field harvest, which is, again, not been a short journey. It doesn't promise to be a short journey even looking forward, but it's a journey who I think his time has certainly come from a standpoint of the maturing of both investment coming into the space, and I think, Walt, a recognition by Western growers of its core role in helping bring the technology ecosystem together. So let me pause there and pass to Gil, because I'm sure he'll have some additional comments he'd like to add, particularly in relation to his view and his take on the Israeli technology scene. Gil, if you can hear us, I think you're on mute. And let me just put myself on mute here and pass to you.
So hi everyone, and thanks Dharma for this high-level introduction. And if I may add, I think Israeli entrepreneurs had AI and robotics on the radar for many years. There was a lot of background, really local historical experience, especially through aerospace and defense, and also very successful research in computer vision. And this moved from aerospace and defense to fields like automotive technologies. You may have heard of the Intel acquisition of Mobileye for north of $15 billion. And this, and so these were some of the drivers that helped these areas flourish in AgTech, and and this was coupled with another local trend that, especially in the last 2 decades, there was a huge shortage in workforce for agriculture, rising local costs and the effective closure of the borders for cheaper foreign labor. And due to the small size of the country, there was very little workforce flexibility. So many entrepreneurs identified and thought of this field. Sometimes with, it's a naive approach because of the distance from the market, and therefore, different market different market characteristics. But it was still the approach for many of these companies is the focus on initial applications, whether it's a company like a Fruit Spec that started by counting the fruits on the trees to help you plan the supply chain, or a company like Aruga that identified the challenge of pollination of tomatoes within greenhouses, and a very, very robust approach trying to solve for the critical problem rather than the entire solution, and grow from that. I think, as Arma mentioned, the cost of producing robotics is difficult and was prohibitive to the growth of some of these companies, but you can see companies like FF Robotics that I think were able to achieve a lot more than companies that raised 10x the amount of money using these unique market capabilities. I think the pandemic had a big hit on the progress on these companies, especially those that didn't have a footprint already in the market. Now, some of the trends that we see, and I think it's typical for Israeli companies, is to look at breaking the market into different segments of the value chain, and looking where software and where integration is needed, rather than looking at building a full solution, again, due to the cost and the distance from the market. So it can be companies that built, that retrofitted old devices like tractors with I guess a kit that can turn old tractors into autonomous vehicles, or companies that again built software platforms, and that's on one end of the spectrum. And on the other end of the spectrum, companies like Blue White Robotics or companies like Trellis, that their focus was on integrating different technologies and closing the full end of the supply chain. And Blue White Robotics built a platform that they believe will enable large growers, be platform agnostic, and they can do large-scale operations, leveraging on their experience from large-scale aerospace automation, or companies like Trellis that just think of the entire supply chain. Another interesting approach was a company like SkyX that, rather than investing in building large and expensive hardware, use the approach for a modular fleet of autonomous drones, again, leveraging from aerospace and defense assets and technology assets in Israel. And I'll pause here I don't know if people have any questions about the development in Israel and different trends.
You know, we would love to take questions, Gil, but I apologize. We're on kind of a tight agenda, so we're going to forego the questions at this point. I'll say thank you to both you and Arma for joining us today. We know you're busy, and we appreciate you coming in and giving us an update on the Israel scene. With that, we will actually jump to two of the Israeli startups that you mentioned. We'll start with Avi Kahani, who's joining us from FF Robotics.
Oh, this is Pat Pinkston. Actually, Avi and I will be joining you together. Good morning, good afternoon, or good evening to wherever time zone you're in. I want to thank you to the Western Growers Association for hosting this, and it's really refreshing to see an organization pulling together an integrated approach and providing transparency to growers and producers. As I said, Avi Kahani is with me. Avi is the CEO of Fresh Fruit Robotics, and I'm Pat Pinkston. I'm an advisor to that organization. It was great to hear Arma say about the innovation and maturity of these solutions. I think what you're going to see in this particular case is that not only is there innovation here, but it has now reached a mature site. As Gil pointed out, the Fresh Fruit Robotics team has been working on this for a number of years, and we would like to say that the future of fresh fruit harvesting is actually today. So if you go to the next slide and kind of kick off the video.
It's so successful. Just quickly, because we do need to go, but there's the political will.
So this is a video actually of the 2019 harvest that the machine from Fresh Fruit Robotics had provided. You can see that this machine is trying to emulate the hand harvesting that comes from those that work in the field. It's using image processing and AI machine learning. It identifies, classifies, and selects the right fruit. There's very gentle handling from the tree to the bin with a stem cutting station you can see there. It picks a wide variety of tree fruit using these robotic arms with a linear motion and a very gentle gripper. It's a very simple design, mechanical design, to provide for the uptime and can work at night and has a proven gentle binning and bin handling equipment. So if you go to the next slide, this is the current iteration of that machine. Shortly we'll have a video out for the 2020 harvest that is provided. There are some additional improvements of this machine, including integrating bin handling into the machine, where you can actually use the existing bin handling equipment and bin handling approach, as well as some additional improvements in other areas of the machine to help it really provide the best results. Again, this is all being done with a 35 horsepower, simple kind of design that really can provide extreme value for the growers and producers. Next slide, please. And of course, we want to say thanks to those growers who provided the support in revising their orchards, moving the whole industry forward in a way that not only benefits the fruit, but really enables robotic harvesting to occur. We've been able to be fortunate to deal with those growers, as well as have great industry support from folks like the Washington Tree Fruit Research Commission, Inez Hanrahan and that group, as well as Karen Lewis from the Washington State University Extension Group. Again, one of the focuses of this conference is to try and find a way to collaborate and integrate, and we worked very hard to try and do that with the other industry groups that are out there. Next slide, please. Of course, we talked a lot about the cost and quality management. How do we automate and mechanize harvesting and the other operations in the orchard? But we also want to make sure, back to again, this theme of having an integrated system, how do we focus as well on sustainability, the documentation, the traceability that's being demanded today, providing insights by tree and by fruit location on the tree, and then working with partners and collaborating with the industry to make sure that the appropriate actions can be taken, hopefully in real time, to provide the optimum outcome and the ultimate sustainability for the environment, for the producer, and for the growers, and for others engaged in this industry. Next slide, please. So we showed you the earlier a picture of this, the FFR robot, which mechanizes and automates the operation, has 12 robotic arms. There's 6 on each side. Using machine learning and AI, as I talked about, a simple mechanical design, proven conveyor and binning system, and can work 24/7. In 2021, there will be machines harvesting in both Washington and the EU. And the intent is to demonstrate further the machine function, the production rate, and most of all, the quality that comes out of this machine relative to having bin-ready fruit when it comes out of the machine. And we'll obviously be continuing development of this machine, improving the production rate, and focusing on other features and feedback that we get from the growers. Next slide. We're fortunate, again, back to collaboration, to have some proven partners with some proven components. The chassis and power that comes for this machine is provided by Automated Ag, who is well known as manufacturers of harvest aid systems. And then the fruit handling and binning is being provided by our partner Maf Rhoda, who is well known globally for their development and delivery of fruit handling systems and capabilities. Next slide. Of course, as we said, this needs to be an integrated system. And one of the biggest opportunities, in addition to the automation and mechanization of the harvesting, is to provide additional insights for what's going on in the orchard. So using cloud services, the ability to be able to store and access data, provide the data security through cloud services, integrating data inputs from other sources that can help integrate the overall solution, providing reporting and data analytics that really help you not only by tree, but by position of the fruit on the tree to get further insights on what's going on in the orchard. And then using that along with AI to provide recommendations based on their own results and their own impact, as well as global sources that can help better manage and deliver sustainable operations in orchards today. Next slide, please. Again, we applaud what's going on with global harvest automation and the initiative here, the focus on standardization, the ability to provide a solution, an overall solution. I think, as was pointed out earlier, in many cases, the producer, the operator, is the integrator today of a bunch of multiple pinpoint solutions. Finding a way to connect those and provide a broader overall solution set is really what's after. That requires, obviously, the interfaces to be connected and data integration, working strongly with the industry, across the industry on insights that they can have and looking for ways to improve and engage growers, industry partners, and others. And then clearly, all of this has to provide value for the growers and for those that they serve in the industry and for their customers. So that's really an overview. Next slide. That's really an overview of the fresh fruit robotics activity. We look forward to your engagement here this summer and this fall. And we believe that the future of fresh fruit harvesting has arrived with the orchard solutions that fresh fruit harvesting, fresh fruit robotics provides, as well as the overall integrated solution of Orchard Insights. Thank you.
Thank you, Pat. That's great. And our next presentation is another Israeli company. This is Tevel, and this is Yaniv Mor. Yaniv, are you on?
Yes, I am.
Okay, good morning, or good morning from California.
Hey, good morning, California. This is night in Israel right now. And thank you, Western Growers, for having me here. I'm loading my presentation.
And while you load that presentation, it gives me a chance to catch up on an item I didn't cover earlier. Sebastian's a great CEO, but he's a little too humble. He should have mentioned that FarmWise was given the Time Magazine Innovation of the Year Award. That's not an agriculture or ag tech innovation. That's a Time Magazine Global Innovation of the Year Award. So FarmWise building some really cool stuff and an example of it getting recognized well beyond just agriculture. So congratulations to Sebastian and the team.
Okay, I'm ready.
Okay.
So we in Interval developed flying autonomous robots for fruit picking. We developed a sophisticated software system that manage fleet of robots to pick fruit. Here you can see 4 robots walking simultaneously, pick fruit, picking apples orchards. These robots are very flexible, can pick many kinds of fruit, can pick apples, peaches, nectarines, plums, and next year in 2021, we are going to pick also apricot and start citrus. The robots are agile. They can maneuver with 6 degrees of freedom, so they can pick almost all fruit from trees. We can work with narrow trees, thick trees. We allow farmers grow taller trees, breaking the limiting factor of access treetops. Our business is to provide harvesting on demand, provide a service of fruit picking, and later on to move to rental. And the system is equipped with a unique gripper, very gentle. We pick many kinds of fruit, and also as a demonstration, we picked also eggs from trees. The gripper is very unique, very gentle, don't break the eggs. Now the system is very efficient. A single robot pick like a single person. So this 3 or 4 robots works like group of 4 people in the picking rate. The value can bring, we have a highest performance coming with a lowest cost. Performance comes from the maneuverability of the equipment, of the robots, and cost with a unique approach that we take, that we have. From logistics point of view, that the robots are small. It's the weight is 3 kilograms, 6 pounds. 1.5 pound. It's redundancy. If something happened to the robot, replace it. And we also collect the data about fruit quality and quantity. We know the fruit quantity of each tree in the orchard. The robots behave like also like agents, not also pickers, and upload all this data to the cloud. This is our system. System is not a single robot. It's a group of robots grouped together. This system will start work in 21 this year in Israel to pick commercially peaches and nectarines and apples. The roadmap for our R&D is to support more fruit, citrus later, and provide also thinning and pruning with the same equipment, and also goes to more varieties of orchards, not only thin orchards, but also thicker ones. Commercially, we plan to be commercial in Israel this year, and also in Spain. A year later, we're planning to go to California and Washington State to pick apples and stone fruit, and a year later to support more fruit in more countries like China and Brazil. This is our commercial roadmap. We are a group of 38 employees in the company, including PhDs and experts in the field of AI, talented and experienced team. And we also have agronomists in the team that support our development and recommend about the right path for the development. And this is our vision. Our vision is bringing prosperity to fruit farmers around the world. And we believe that the flying robots that we developed can bring, first of all, solution for the shortage, the massive shortage, can bring, allow farmers grow taller trees. This is extra tens of % of crop for the same area. By the way, these trees that you can see here, they're very tall. These are 4.5 meters apple trees, which is extra half a meter tall from the standard. You can see extra yield on the treetops. And of course, we are planning to reduce the current cost, the cost of labor that increases all the time. We can see in the last 10 years that the costs are rising all the time, and we want to stop it. And we want to even reduce this cost. Thank you very much.
Thank you, Yaniv. Great overview. Thanks to both of you for presenting that to Pat and Yaniv on those two startups. We will now take a break. We'll give everyone about 30 minutes to go get some coffee, check some email, do some stuff that gets you away from Tulare for just a few minutes. We'll reconvene at 11 o'clock with Dave Puglia's presentation. And I would just mention one thing. There's a lot of great things that are old school, if you will, about agriculture, including barrel racing. When Dennis and I were here, we saw some barrel racing as we were doing a site inspection for this facility. And rather than do a barrel race, we thought the new tech version of the barrel race could be the burrow race, right? So the Augean burrows are over here on the side. I've worked with Charlie and the team for a couple of years now. It's a fantastic technology. I'd recommend taking a look at it. It's not directly harvest technology, but when you talk to growers, it's absolutely harvest related, right? So what the burrow does is it takes the fruit once it's been harvested and takes it back to the truck. And that may seem like a small thing, but believe me, from the results he's seeing in some of the vineyards he's in and some of the crop operations that he's in, and Chris from the Augean team is here, they're seeing some great economics for the growers around just moving the fruit. So there's a lot of harvest to be automated. There's a lot of harvest complementary stuff to be automated. We think the burrow from Augean is a great example. So take the break. We'll reconvene at 11 o'clock, and thank you. Convene, I'd like to bring to the stage the Western Grower President and CEO, Dave Puglia, who will let everyone know exactly how big a deal this is to WJ and exactly why it's so important.
Thank you, Walt. Good morning, everybody. It's great to see a lot of friendly faces here, a lot of folks I haven't seen in a while. I'm the least important person you're going to hear from today because I know the least about all of this, except that I understand, probably as well as anybody, the imperative behind AgTech and innovation in our sector. And that's because my background is as an advocate, which is a polite way of saying lobbyist. I've spent a lot of years talking to legislators and regulatory officials, both on behalf of this industry and prior to Western Growers on behalf of other industry groups and other clients. But in the last 15 years for Western Growers, I've endured a painful journey on behalf of our members in the realization that in spite of our best efforts, our best arguments, our best projections of economic realities, in this state and increasingly in other parts of the United States, and I would even say parts of the world, the laws of economics seem to be either misunderstood or deliberately ignored when policy is made. To give you an example of that, last night the city of Coachella down in the desert passed an ordinance that requires what they call hero pay, or you can think of it as hazard pay, incrementally bumping up by $4 per hour the wages of people working in the ag sector. Now, we can all agree that the good men and women who have continued to work in our fields and our processing facilities during this pandemic, because they are essential, are heroes, absolutely. But the laws of economics weren't suspended when the governor declared an emergency and when this pandemic hit. You cannot simply assume that farmers and processors and shippers who have long-term contracts, or at least seasonal contracts, to deliver their produce to grocery chains and food service companies can absorb another $4 per hour when that wasn't baked in the contract. Nor can you assume that the buyers of those products, the large grocery chains and food service companies, will happily absorb that cost. They won't. They have options. They can source fresh produce from other places in most cases. We have a couple of commodities that we produce in California that are hard to produce elsewhere, but many of them are not hard to produce elsewhere. I've seen in 15 years as an advocate for this industry the increasing movement of capital from California to other states and increasingly to Mexico and other parts of the Americas. It's not because any California grower wants to leave California. It's the last thing they want to do. Greatest climate, Mediterranean climate, great soils, historically pretty strong water supply, although that's gotten shaky too. But as they've faced these increasing mandates and expectations and costs and legal jeopardy that comes with the mere act of hiring employees, they have to do what's right for the next generation and for the people that they serve. And that increasingly means not investing in California. So why do I mention all that? It's a little bit of a dark picture. About 7 years ago, our outgoing board chairman, Bruce Taylor of Taylor Farms, delivered basically a command, I think, to the industry as he gave his exiting speech as chair. And he made a very, I think, simple and powerful point that brings us all the way to where we are today, which is that in this industry, in the fresh produce industry and specialty crops, we have a whole bunch of very fierce competitors, highly innovative in their own right, but in cutthroat competition with each other, even as they do business with one another. In some respects, they'll also be fighting for the same customers out in the marketplace. And innovation and technology, Bruce went on to explain, had become sort of a proprietary venture, that the large players in the industry were able to develop their own skunk works and develop their own innovations and try and keep it hidden from the rest of the industry, and maybe you get a leg up for 2 or 3 or 4 years until too many guys in pickup trucks see what you're doing and then try to mimic it. And he said, that's dumb when you think about it. Because ultimately, whatever we do in our skunk works, you all are going to find out about it and you'll mimic it and you'll catch up. So we get a short-term advantage, but in the meantime, we're all spending a lot of money to try and get that short-term advantage over each other in the marketplace. Why don't we instead move more as a collective to enable the fast development of technology that goes at some of the very root cause headaches that are threatening our viability, especially in California. And he was talking about legislative mandates, regulatory mandates, compliance costs, et cetera. And he's right about that. I mean, the simple fact of the matter is, if the industry can't figure out how to end around the policymakers who refuse to get it, who refuse to understand the nature of these businesses and the economic realities affecting them, then we're not going to make it. We'll have increasing flight of capital outside of California. Nobody wants that. That was really the genesis and the rationale for our initial investment in innovation and technology. It takes the physical form of our innovation center in Salinas, but it has morphed into something much more, thankfully, which is what we're doing here today. And it's what gives me the greatest hope that this industry will overcome all that has been imposed on it and is still going to be imposed on it, unfortunately, by bad policymaking. It's really interesting to see now the attraction that we've created to the specialty crop industry, to fresh produce commodities in the West. When I first got into this discussion, as we launched our innovation efforts, one of the obvious realities was that AgTech capital and investors, the companies that are interested in creating prototypes, they were all in for corn and soybeans, but very little attention to the specialty crop industry, and that's understandable in a lot of ways. We're not a monoculture or biculture agriculture. We've got 400 commodities in California alone. So that's a lot to try and tackle if you want to play in AgTech in specialty crops. But I think what we've been able to do, and again, this semblance is I think demonstrative of it, is collect the right players across the grower and shipper and processor segment, the VC and investor segment, the industry partner segment, the providers, and enable us to all envision what we can collectively do to both tackle across the hundreds of commodities that represent specialty crops, the challenges that afflict us, and also create immense opportunity for those who are willing to take the dive. But that only happens with focus, it only happens with organization, it only happens with collective effort, which a lot of farmers aren't real fond of. Farmers are notoriously individualistic. So I think this today represents to me not only a really big, audacious goal-setting exercise to automate our industry, but it also, to me, represents a real moment of celebration that from a dispersed and somewhat chaotic conversation that some of us were having 10 years ago, 8 years ago, we now have a much more focused and determined conversation and action built around that. And that's just, to me, very, very exciting, because I have felt for some time that, again, we in California especially, and I would say this would be true for producers in other Western states as well, we're living on borrowed time. Our workforce is aging out. We're not replacing them. Wage costs are going up. Cost of hiring people and the litigation that we often face is going up. All of it is going the wrong direction, and it's happening more quickly now. So we have time pressure, and I think this initiative is going to be driven in part by that time pressure, but also by the opportunity that exists if we get this right, and I'm confident that we will. So it's a really interesting moment, as I said. I feel almost like it's time to declare our moonshot to automate 50% of this industry. It's a hell of a goal, and if we make it, we'll have a lot to celebrate. If we fall a little bit short, We'll just keep going until we get there. Let me take a couple of minutes here to mention several of our domestic partners. We have really awesome partners in this industry. I'm really proud of the way we've, again, coalesced around this challenge. So I just want to call out several. Some of them are here in the room. Some are watching online, streaming. From the California Citrus Research Board, Marcy Martin. California Citrus Mutual, Casey Kramer, who's here but I think went out to take a call. California Fresh Fruit Association, Ian LeMay, my friend back there. Driscoll's Strawberries, Grimway Farms, the California Table Grape Commission, Kathleen Nave. UC Riverside, with whom we have a memorandum of understanding, Dr. Ash Al-Karani. Ash, did I say that right? Awesome. We have an MOU as well with the Washington Tree Fruit Research Commission and his Hanrahan. We have an MOU to announce today also with the California Strawberry Commission. Rick Tomlinson, their president, has agreed to sign an MOU, so he's and his commission is now a full partner. And I also want to mention I have several of my Western Growers directors who are either here in person or online. I'm not going to call them all out because I don't frankly know who all's online. I know my chairman is, Ryan Talley. So hello, Ryan. Neil Callis is here from our board, and also Don Cameron, who just recently left our board. We've had really incredible support from our board of directors over the years for this initiative. It's something that requires an investment of not just money and time, but what we've done is really invest with some risk our own reputation, because a trade association is only as good as what it delivers at the end of the day. And with a pretty major investment in money and human capital, we're putting our reputation on the line too. And I just want to thank our board of directors, both current and previous, for all the support they've given to these initiatives. And then, as I mentioned, all the names of our partners. I can't say enough about the other industry partners, my counterparts with the other organizations that are involved here and have come here today. For all of you to know, we're not only tightly wound together around AgTech, but Ian and Casey particularly, and myself and some others in this industry are wound very tightly together on the really hard stuff of fighting bad public policy and trying to get some good public policy passed. So know that we have a very, very tight alliance in this industry, and that all weaves together with what we're doing here in AgTech. So exciting time, wonderful to be here and be a very, very, very small part of it. I want to thank all of those who've committed their time and their energies to this initiative, and let's go get it. Thank you.
Thank you, Dave. Great overview. And we'd now like to bring up the aforementioned Inez Hanrahan to talk about what Washington Tree Fruit Research Commission is up to and what they'd like to announce today. So Inez, please join us.
Okay, let's see if technology works. Okay, seems like the microphone is working. That's always very reassuring. So good morning, everybody, and good evening for those of you that are on the other side of the globe. I'm Inez Hanrahan. I'm the Executive Director of the Washington Tree Fruit Research Commission, and I'm really glad to be here to join you today. As you all know, Washington State is also a big agricultural state. Just like California, we grow just about 300 crops. But who I'm representing here today is the tree fruit industry. We are the leading producer of tree fruit in the nation, of apples, pears, and cherries, and we're also producing a considerable amount of soft fruit. And I am, as the director of the Tree Fruit Research Commission, representing those growers. The Tree Fruit Research Commission was founded in 1969, over 50 years ago. And those that founded this commission, they actually had a vision. And their vision was they wanted to bring automation to tree fruit orchards. That was their goal 50 years back. And I'm really pleased to see that now finally their vision the vision of those forefathers that grounded this commission is maybe coming to bearing in the next couple of years. I want to run you a little bit through some of the history that we have experienced in the Pacific Northwest, especially in the tree fruit industry. One of my predecessors, Dr. Jim McPherson, created the first technology roadmap that we used to guide our actions. It was in the early 2000s. Based on this roadmap and a national coalition that was built around this, we focused on creating better varieties. You have heard this earlier speakers, they alluded to this. It's really important to have varieties and systems that are suitable for automation. If you don't have that, you cannot automate. The second really important thing that Mr. McPherson realized and that he made part of the roadmap is that maybe you need to first take some smaller steps and bring some mechanical help into the orchard, and that it's not just about doing the picking robot first, but maybe also doing some smaller steps in between. As a result of this, we are now basically universally using self-driving platforms in our orchards. So those two examples are very important steps that also highlight how important it is to have a plan, to have a roadmap, just like what we are trying to do now with this initiative. Now, fast forward, 10 years ago, we started to collaborate with some public-private partnerships, and you saw one of that partnership with FF Robotics, because most of the cost, the labor cost related to running an operation in our neck of the woods is in harvest, in the actual picking. For example, we have 13 billion pieces, single pieces of apples that have to be picked every year. It's a motion, a very specific motion. And if you put all the apples together, they can circumvent the globe multiple times. Now, what we did is we tried to develop these public-private partnerships because we felt this was very important to have not just universities involved, but to have a commercial driver in the system. Because ultimately our goal was we wanted to create a solution, the solution of automating the picking of fruit by having a solution that works for all the growers, works for small growers, for big growers, for organic growers, works across irrigated perennial crops ultimately. And it needs to be a solution that is ultimately driven by the economics of farming, and several of you also alluded to this. It is really, really important to create solutions that are sustaining the farms and that keep them profitable. So otherwise we do not have a solution ultimately. And for this reason, we are really, really pleased to join the Western Growers Harvest Automation Initiative, because we feel like we need to still reach this next step. The next step would be the full implementation of harvest automation into our cropping systems and in the 20 top cropping systems of specialty crops here in America and in the world. We have done really well creating vision systems, creating chassis, creating transport systems and arms, and some sort of containers to store the fruit or to keep the fruit. But what we're really still lacking in all of the equipment is the integration, the seamless integration. And what we're still lacking is having a tech stack that can work and that will ultimately make the technology cheaper. So I'm going to announce today that the Washington Tree Fruit Research Commission has decided to support this initiative by giving $200,000 over the next 3 years to hopefully help us get there. And I want to close by saying that the mission of the Tree Fruit Research Commission is to provide, to use science to provide solutions that keep farms profitable and sustainable. And I believe this is a mission that we can all agree on and that pertains to all specialty crop producers. So I am really proud to be able to say that we are joining your initiative, and I am really convinced that together we can get there. Thank you.
Thank you, Inez. And thank you for that generous commitment from your organization. We really appreciate the support. That's a big step. Now we want to switch gears to Wilfred Alber with Roland Berger. Roland Berger is an analyst firm that's taken a look at the automation piece for many industries. And Wilfred's going to bring a really good perspective. He's done some great data digging and some great thinking around our space as it relates to other spaces. So with that, I will hand it over to Wilfred to give us some of his thoughts on this initiative.
Perfect, Walt. Thank you very much. And everybody, I'm really happy to be here. It's a pleasure that I'm able to share our thoughts on automation in agriculture with you, albeit unfortunately not in person. So what I want to talk about today is our view on agricultural ecosystems and how do we cut the Gordian knot, in the sense that how do we drive and accelerate the need for automation in agriculture. And maybe if we move to the next slide. What we can see is that the global agricultural industry has a very large number of challenges. Many of them were pointed out already. One is the world population is growing. It will be about 10 billion by 2050. We will have to increase food production by 50%, and that with already scarce water resources. So clearly, we need to do more with less. That's a very, very real challenge that we face. The second problem is a problem of public pressure. Climate change is seen as a real problem. It definitely is a real problem for agriculture, but agriculture, and in particular large ag, is seen as part of the problem, generating a significant amount of greenhouse gas emissions, being responsible for a certain amount of deforestation. And that is clearly a problem that's not going to go away, and that will force us to do things differently than in the past, be more sustainable, and also communicate our efforts in these activities effectively. We've also heard that there is a long-term trend towards a dwindling rural labor force. Today, being in agriculture is not necessarily seen as a job that people would want to do. The consequences are wage inflation. Consequences are increased urbanization. And the consequence, or one of the resulting factors, is that we have an aging workforce in agriculture. We talked about the US with an average sort of age of around 60 years for farmers, but that's not limited to the US as well by itself. We do see the same tendencies across the globe, whether it's in India, whether it's in Europe, whether it's in Africa, where the average age of farmers is similarly elevated. So that's a real issue. On top of that, we've had a tough time because of immigration restrictions, be it Brexit and Europe as one example, or the situation that we faced in the United States, and because of the pandemic. So we really do have a burning platform around the availability and affordability of labor in agriculture. One of the solutions is to say, okay, listen, let's move production to other regions. And we just heard it, that that's something that people are currently contemplating and have to contemplate in order to safeguard their businesses. If you look at Europe, the same trend is visible. About 40% of vegetables and fruit is the self-sufficiency level in Europe today. The rest of the production has already moved to Northern Africa and other regions. Now, that may help as far as immigration and access to labor is concerned, but it does also create its own complexities in terms of value addition within our regions. It does create complexities in terms of strategic dependencies. So clearly, we have a very strong burning platform. And maybe we can move to the next slide. The solution, or one of the solutions, if you don't want to move production, is really technology. We have to find ways to become much more efficient in the way we do things. And I think some of the topics or themes are around precision, value addition, integration, and sustainability. precision farming, with its promise to look at production at the level of the single plant or the single animal, to realize higher yields, to ensure better quality, ensure traceability, and at the end of the day, more sustainable and animal-friendly products. Clearly something that we want to go after. Sustainability is needed because we need to make sure that on the one hand, we limit the amount of input, be it pesticides, fertilizer, herbicides, and we close loops, reuse as much waste as possible, and also find new ways to value add by finding applications for that waste that allow us to sell byproducts or additional products and improve farm economics that way. And last but not least, we have the opportunity to look at integrated solutions, which clearly are again something that is required by customers today, where we would like to make sure that we have full transparency across the production process. So technology clearly is the way forward, and I think that is what is exciting about this initiative as well. It is a very, very important part, a very important component of driving agriculture to the next level. If we go to the next slide. Technology is important, but if we look at what technology means, it is something that's also highly complex. We have a large array of technologies. We have robotics and automation, imagery and sensors, biotech, big data, AI, VR, AR, platforms, so a whole range of technologies that we can leverage and need to figure out what is the right combination of these technologies. And at the same time, we have a very dynamic and very complex ecosystem around the technologies. Today, everybody, whether it's retailers, whether it's the OEMs, whether it's suppliers such as Bosch or technology companies such as Trimble and Microsoft, or a whole range of startups, has a stake in this game. And while this is a big opportunity, because I have a very, very large range of companies that I can work with, and I can try to sort of cooperate with to find solutions that address the problems of farmers, it's also difficult in the sense that it becomes hard to figure out who should I work with. It's difficult for startups to understand where does my technology fit in and who can I partner with to really make sure that I get the right impact in the market. And it's equally difficult for companies, whether they are so Bosch or others, to see which startup can I really work with and how can I sort of evaluate all these different opportunities and technology solutions and integrate them in my portfolio, make sure that I can work with these startups and drive the industrialization and the scale up of these solutions. So it is complex to find your way in this ecosystem. The second slide, or the next slide, shows it's not only a complex environment, it's also an environment where technology really enables a lot of shifts in the value chain. There's a rebalancing of power in the value chain. And a good example is a little bit the tussle between the push system that we had in the past, basically the OEMs and the seed providers pushing their solutions to the growers, and then the whole thing went from there, towards a more pull-oriented system where technology such as blockchain today gives retailers an opportunity to say, okay, listen, I really understand the customer. I know what happens in terms of trends, what happens in terms of fast and slow moving SKUs, and I can use my customer intelligence via technology to really now work down with my partners in the upstream value chain to now say, okay, listen, let's work on quality, let's work on transparency, let's work on sustainability standards. I need it because my customers want it. And by the way, let's also look at the definition of a go-to-market for product innovation and the coordination and bundling of input factors. So this kind of shift of balance is a challenge in some sense for growers. It's an opportunity potentially for the initiative that we have over here, because it definitely lends additional push towards taking innovation and making it work within the agricultural value chain. So we talked about the complexity of the ecosystem. We talked about the volatility in terms of the value chain and who is going to capture what kind of part of the value chain. On top of that, on the next slide, we have a challenge, or we have the challenge of the complexity of the technology itself. If we're talking about robotic farming, this is a hard problem to crack. It's a hard nut to tackle, right? The reason is we have to worry about a whole range of technologies, learning and adaptation, for example. We work in open systems. It's not enough to train my AI once and then run with it. This is not a warehouse, right? Things change in an agricultural setting. I need to be aware and handle cloud integration and edge computing. I need to understand geolocation, vision and sensing, and that in an agricultural environment, which again is unstructured. I need to think about scaling my technology and run swarms of independent robots through fields or through rows of trees to be able to generate the kind of impact and the kind of efficiency that I need to replace human labor. And that requires me being able to drive or to develop and run autonomous vehicles that operate as a swarm. I need to think about pattern recognition and AI, manipulators, actuation, human-robot interaction and safety. So it's a really, really tough, complex problem. And what we'll see on the next slide is that this tough problem is really made so much harder by the kind of environment that we have to handle. We have an unstructured environment. There is mud, there is dirt that's going to block sensors. I need to figure out how to handle it. Driving an autonomous vehicle on a highway, like Daimler does it or others do it today, is easier than driving it on a muddy environment in a field. Looking at the impact of ambient light, of weather conditions, background, changing forms of fruits is a real complication that we need to figure out how to handle. And at the end of the day, we have tough competition. Humans are quite effective in terms of picking strawberries, picking apples. So making sure that my solution is faster and as accurate as a human and really takes care or is able to replace that human in the harvesting process, for example, is a tough challenge. We have a few examples where that's feasible, but by and large, we still are significantly slower than a human picker. We have a lack of standards, and I think that's one of the areas that really needs to be tackled. We have a lack of standards, which does make it very difficult for us to do and drive modular product development. Ideally, what I should do is not reinvent the wheel, but focus on where I'm really very good. Could be a soft manipulator. So I focus on the soft manipulator and the actuation, but I shouldn't be focusing on necessarily developing an autonomous vehicle, right? Ideally, my solution can just plug and play with the solutions that are available in the market. I would want a testing environment that clearly defines the performance of the solutions that we have available. That drives structured competition in that market. It also makes it easier for farmers to understand which technology works, which technology doesn't work, or in which environment do these various technologies work. And last but not least, we also need standards, for example, for homologation, to be able to scale solutions up quickly and across regions. We have a challenge around crop dependency. The fact that we have very different crops is an issue in the sense that the payoff is harder to get. It is harder to attract investor interest and funds to this particular area. And I think that's another area where hopefully standardization and multifunctionality can change the rules of the game. In terms of business partners, we may even have an opportunity to work with non-standard business partners. If we look at the vertical takeoff and landing space, for example, which is the drones that carry people and then hopefully carry us from the city to the airport at some point in time. What we see over there is that, yes, the aerospace industry is interested, the Boeings and the Airbus players, but it's also automotive players. Because they are saying, okay, listen, the production paradigm for these technologies has changed. These VTOLs are basically engines to transport people. They have very high volumes compared to the normal production that I see in an aerospace company. And that is something that as an automotive producer, as an automotive OEM, I know how to do. I know how to do lots and lots and lots of things at a very cheap cost. And here in this particular environment, swarm robots are a similar change in terms of the manufacturing philosophy. I'm going from large equipment to small equipment. I'm going from a few sort of numbers of equipment, a few tractors, to lots and lots of swarm robots. So I could look at other partners, either from the automotive industry or maybe even the consumer goods industry. We have issues around data, the availability, the use of data, who owns the data is one side of it. And the other thing is really the availability of testing data. We talked about working together and coming together and driving the industry forward. Data and testing data is another area where we can really need and profit from industrial commons, meaning a common set of data that is accessible for everybody so that people can quickly test their new technologies and understand where they stand and where they need to improve. And again, that's something that does exist in other industries. If you look at the telematic solutions in commercial vehicle applications, there you can get access and buy access to standard data that helps you to test your algorithms and bring your solution to market with a significant amount of confidence that whatever it is that you've designed actually works in real life. We need the same thing over here. Right? And then last but not least, obviously, we have to think about some of the complications. Do we sell a service versus do we sell machines? So I think what I'm trying to say is the technology is extremely important in today's agriculture. It is today very complex. The challenge that we're solving or trying to solve in terms of driving automation in harvest is extremely complex. And that's where, if we go to the next slide, some analysts, and these are not my numbers, right? But some analysts clearly are of the opinion, this is a very, very hard nut to crack. I think all of us agree that the current solutions are in the prototype or sort of semi-commercial or pre-commercial phase of their application vis-a-vis a potential rollout in the fields. Now, this particular analyst looked at the market and sort of believes that in terms of fresh fruit and citrus harvesting, penetrations by 2030 would be around 1 to 2% and 12 to 14% in 2040. That is just not good enough, right? This is not a situation that we can accept. We need solutions much, much faster. We need penetration much, much quicker. And the way to get there, at least some of the components, can be gleaned from other industries. If we go to the next slide, we can see what, again, happens in other industries. And this is an example of the automotive industry, an example of hydrogen trucks. Hydrogen trucks, again, is a technology that will happen, that has to happen, but it's at the sort of at the beginning stages of rolling it out and making an impact in long distance transportation. And here, really large companies that have access to a large network of sister companies such as Hyundai, and Hyundai has a very distinct culture. They do like to do things by themselves. But even Hyundai says, okay, listen, this won't work if I do it by myself. I need to work with others to make sure that I can create an ecosystem from the technology that I provide to the technology that's needed to fuel my trucks, which is the hydrogen generation, to the distribution of hydrogen to make sure that it's available for my customers, to the service part, so that my customers can actually run this technology in a pay-per-use model, which means that I take, Hyundai being a big company, they actually take the technology risk till this technology is rolled out and stable. And then to the demand part, right? To the customers, the fleets that will actually use this technology. It's a complete ecosystem that covers the various aspects that are necessary to establish that the technology works and to establish a framework that's then scalable. This is the way how companies today have to work in an environment where technology is complex, in an environment where technology changes very, very rapidly, and in an environment where, quite frankly, nobody by themselves has the capability or the money to solve this problem, right? So for us, what it means in the agricultural context is sort of, at least some ideas are on the next page. We go to the next page, please. So what it means is we need to, and I believe that the G8, the Global Harvest Automation Initiative is a key enabler for this activity. We need to defragment the AgTech community. We need multi-centered global hubs that leverage the capabilities of all stakeholders. And I think it's great that we are bringing everybody together and we are bringing people from different parts of the globe together, because agriculture, AgTech is a global phenomenon. There is capability all over the place and we should leverage it and use it. We need, in my opinion, a common set of global standards. We absolutely need to drive modular development to be able to scale, to make sure that we don't have to test too much and have to have interoperability and clear external standards in terms of testing and homologation. Reusing rather than reinventing is really the need of the hour. If something is good, if you have a better idea, okay, improve upon it. But if you have an idea to improve something else, just reinvent only what you need to reinvent and just run with the rest and use a platform that enables you to get to market faster. Data accessibility, we talked about it. We believe this is something that needs to be an industry common. Partnerships for testing and deployment are extremely important. And this initiative is a good opportunity to bring various players and also the users of technology together and drive automation in agriculture. And last but not least, we need to continue to focus on design to scale, meaning multifunctional, multi-usage, plug-and-play design. And we need to be open to partner with companies to be able to scale and roll out technologies quickly. If you look at the example that we have currently with the COVID vaccines, yes, there are some companies that had, for example, BioNTech had a good idea, had a good vaccine, but we still need Moderna to make sure that we get this thing on the road and produced in mass and distributed quickly. And here we have the same phenomenon. There can be very good ideas within startups, but working with established players will enable us to bring these ideas to bear much, much faster. With that, I think I'm sort of done with my initial thoughts. My contact data is on the next page. So if anybody has any feedback or comments, I'm more than happy to engage. Thank you very much for having me.
Thank you, Wilfried. Great content, really appreciate it. Global collaboration to solve some really hard problems. We obviously agree with Wilfried's recommendation, and I think it's evidenced by what you've seen this morning and what you'll see this afternoon. So with that, we will take a break. By my clock, it's 11:48. We'll give everyone roughly an hour to do a couple things. Number one, there is some great Mexican food out the side of the building here that's ready in about 3 minutes. Number two, the burros are available for discussions. Number three, collaborate with each other, right? We brought this group together in Tulare to have some great conversations. Lunch is a perfect opportunity to do that. And we will reconvene at 12:45 with the afternoon portion of the program. All right, folks. 1 minute warning. Get going here for the afternoon session. All right. Well, good afternoon, folks. We'll kick off the 1 o'clock hour. For those of you who are not in Tulare, you missed a treat. The Mexican food was as advertised. I'll be looking for a couch in about 40 minutes for a nap. For this afternoon, we're going to focus on a specific part of the Global Harvest Automation Initiative. I mentioned the 4 parts this morning. We're going to focus on the technology stack. We believe this is the key part of the initiative that enables the entire acceleration of innovation and the startups. The goal of the tech stack is to allow the innovators to take some of those key technology components, and you heard a lot about this morning, right? Let's reuse some of the stuff that's already out there instead of building everything yourself. So what is the tech stack? Why does it matter? Why is it so important? Why are we going to spend the afternoon talking about it largely? Well, at a high level, the tech stack is a really good set of documentation, really good book, right? And I know Dave's sitting back there going, that's great. Well, can't we go to Amazon, pick up something used? Not in this case, right? So what we're building is brand new. And you think of all those key technology areas that I mentioned that harvest automation requires. You heard about it from the startups. You heard about it from the growers this morning. The imaging and vision to capture millions of images of fruit and veg. Separate all them out in terms of fields, plants, and weeds. The artificial intelligence, we heard that a lot this morning, right? AI and machine learning, you've got to interpret those images and educate the robot arm and the end effector on what to pick and what not to pick. That is all a very manual and labor-intensive process on the coding side. We need to reuse more of that. The robot arms to get the harvest mechanism into position. We've got robot arms, right? Why is every startup building robot arms? We can build robot arms for them, integrate them with other robot arms that are already out there. And finally, the tractor. Why are we building tractors for every robot startup when we have a lot of good tractors of different colors all over this place? And in fact, I would argue, talking to a lot of the startups, that this is why stuff's not moving far enough along. You guys saw the numbers, and I'll remind you from Wilfred before lunch. At current course and speed, we're at 1 to 2% robot harvest in 2030. We're at 12 to 14% by 2040. Everyone in this room knows that will not get us there. So we have to fundamentally adjust that curve in the next couple of years. So that's why the tech stack matters. That's why we're so focused on it. Commoditizing that tractor into some industry standard tractors that are out there, those robot arms and sensors and imaging systems that replace some of these proprietary solutions. Those are the big get for us. And building that integration technology is a key piece, but systems integration behind it equally important. We talked about this before. How do we get this stuff to happen? You have to build it and you have to support it. So we're investing in that piece of it. And the good news is I can't announce anything today, but some of the folks you heard from today and some of the folks that you know that are in market, they are supporters of this approach. They are supporters of the stack. We will be announcing them as they become users of the stack, because nothing should influence an AgTech entrepreneur more than other AgTech entrepreneurs who are further down the path using something like this technology stack. And we're confident that that's going to happen. So we're going to provide systems integration capabilities to the startups that participate in our cohort. So again, for the ones that are out there in front, that WGA and our industry partners say should be supported, Those are the ones that'll get this higher level of support from us. We're happy to do it. So that's the tech stack. It's a good book with systems integration behind it. How do we build all this and how do we make it happen? We're going to define and build this tech stack in about 6 months or less. And it's going to involve recruiting subject matter experts on robotics topics from a wide variety of partners. We will engage 15 to 18 subject matter experts from robotics and tech companies and 4 to 6 subject matter experts from grower and producer companies. They will work for a 12 to 13 week period on this tech stack to get it built, documented, and out there. And my colleague on this panel, Mike Dentinger, is going to go deep on this stuff. But at a high level, that's the big commitment that WJ is making today. We're going to invest in the establishment of the tech stack over a 6-month period and the support of systems integration behind it. Those are our 2 big bets. The initial tech stack can be considered a 1.0 version focused on platform interfaces. Over the long term, the product roadmap will build out additional components and integration capabilities based on startup and innovator feedback. Think of this first tech stack 1.0 as being a traditional reference architecture like IEEE 802.11, which was established 20 years ago and has set the standard for Wi-Fi implementation since then and has evolved significantly. That's what we're trying to build. Once Tech Stack 1.0 is launched in Q3, systems integration begins in earnest, and the product roadmap of development priorities for Tech Stack 2.0 can begin. Growers, startups, and tech partners that provide some of the components will contribute to the priority setting for Tech Stack 2.0, and it'll be a much larger initiative. Again, we're going to do 1.0 in 6 months, start to finish. 2.0 is going to probably take 12 to 18 months or longer with a much bigger investment. Tech Stack 1.0 also focuses on some of the key hardware components, tractors, robot arms, and sensors. How do we get the startups integrating with those components? That's the starting point because that's what we heard from the startups and from the tech companies and from the growers is the most needed. But we're not going to stop there. There will be some known gaps in 1.0, and we'll get those fixed and prioritized in 2.0. And we're going to get focused on the software piece of it, right? So again, think artificial intelligence, think shared code base, things like that. There's a lot of opportunity to come up with shared resources around image libraries, artificial intelligence code bases, and other things that are not hardware but can enable hardware. Again, we saw this from the presentations this morning from both Sebastian and some of the startups and from Wilfred, being able to collaborate and build this stuff collaboratively instead of competitively, to Bruce Taylor's point, will move us all further faster. At a high level, think of Tech Stack 1.0 as enabling AgTech startups to plug into ag equipment manufacturers, equipment dealer networks, and some component manufacturers. Tech Stack 2.0 then takes that, builds on the effort, and enables AgTech startups to plug into more of Silicon Valley with the crowdsourced imaging that I mentioned earlier, image tagging, shared artificial intelligence and machine learning code bases, and don't forget these, the big data tools to make all of it happen, as the massive amounts of data collected by these harvest automation solutions can get used properly. I've talked to multiple startups about what access to an image library could mean when you're starting a harvest startup. Having access to, say, an apple library, a strawberry library, a broccoli library that you can start designing against and developing against at the starting point. When you talk to some of these startups that are out there in the market now, it's a 6 to 9 month head start if we can put the image library together for them, an image database together for them. We're building toward enabling that. We want that to happen. That's good for all startups. At the same time, I want to be clear about one thing. WGA is not asking any harvest startup to give up any intellectual property or now or in the future. If you have intellectual property you've developed, keep that. All we're doing is setting the floor. So we're going to put this integration stuff out there. We're going to make that a floor that's available for everybody. What I hope happens, what I think is going to happen, I won't even say hope, what I expect to happen is that we will end up with entrepreneurs commoditizing the tractor, the robot arm, and the sensor layers, because those are great players that are out there in market. but the actual time that the entrepreneur invests gets focused on artificial intelligence to drive those imaging libraries into robot arm action and the end effectors themselves. Because we all know that the most sensitive part of this whole process is the picking of the fruit and veg, which is super hard, super complex, and deserves some IP. So that's my expectation, is that the smart entrepreneurs will spend time there and leverage the industry standard stuff that we're going to develop. The other point to make on this is that WGA will not be in the business of creating IP and licensing it. That's not the purpose of the tech stack. It's not the purpose of this initiative. We're going to publish this, help folks use it, not get in the IP and licensing business. The win for Western growers out of this is the startups that can scale faster and the growers' crops that get harvested or harvested faster because of the automation, period. We're not worried about the rest of it at this point. That's the win all by itself. So that's an overview of the tech stack. What it is, when and how it's getting built over the next 6 months, how we'll provide systems integration resources and build that roadmap for Tech Stack 2.0. I would now like to introduce Mike Denninger from Trimble, who's been with this initiative from the early days and is going to drive a lot of the actual development work for Tech Stack 2.0. Mike has done a fantastic job of driving the process to this point, documenting it, and telling the story. So I'm going to let him share it with you now.
Have you started the presentation yet? Okay, perfect. So thank you, Walt, for that introduction. And I'm Mike Denninger. I'm with Trimble. A lot of you know, as we try to drive tractors straight is our general claim to fame. The ideas that are going to be presented here, and knowing that this is 15 minutes, we're only going to be able to dive so deep, but they're the collective ideas of a group of people who've actually worked quite hard to put this together, to pick a starting point, to get this initiative moving forward. So despite the fact it has Trimble on the logos, on the presentation, it's a collective effort. And I've been very impressed with the people who spoke before us today. Many of the themes that they brought up, and I hadn't seen their presentations, will appear here also. And these are evolving as the fundamental challenges for success. Dr. Elber, who spoke just before lunch, really elegantly articulated many of the challenges and the real-world scenarios from taking an idea and the roadblocks to getting it into an actual field sustainable solution. So here we go. So people here are in the specialty crops. You know that this industry has headwinds. The crop diversity, the 400 species in California, the harvest timing that has to be very precise or you lose your entire investment, economics of being a small market segment trying to get high automation, the economics don't work. Regulation, equipment complexity, commercial sustainability, all of these things are headwinds to this industry. And if these were easy problems, they would have already been solved. There are actually some good specialty crop harvesters out there, but the majority of the industry is still harvesting by hand. And so we have very simple goals here. Number one, build a harvest automation ecosystem. And the success is defined by, and I think Walt mentioned this earlier, 50% of harvest is automated in the next 10 years. It's a very aggressive goal, and as Dave had said, if we fall a little short, we'll just keep going. Okay. Now, here's the strategy on the tech stack. We visualize the end state. There's many end states, but in the end state, it is a functional, sustainable harvest mechanism that automates and reduces labor, increases safety, increases food safety. We separate the task out. We segment. We divide and conquer. We identify the gaps that are needed to be filled, and then we have to always propose a very clear, viable commercial model. We're going to use an 80-10-10 strategy, 80% off the shelf, 10% modified off the shelf, 10% new, because platforms are off the shelf these days. GPS RTK is off the shelf these days. Many of the implements and things are off the shelf. We heard several of the speakers talk about system integration difficulties, not having someone who can do it start to finish. We're going to try and make that easier. Heavy reuse of components. We have several companies, and Trimble's one of them. We're in ag, but specialty ag has always been a mystery to us. We can't figure out how we play and how we make money, essentially. But by normalizing things and having common modular architecture, you enable us to size markets and prepare for reuse, and you provide a value proposition. Share, publish, and educate, specialize, and the specialist is let the specialists do what they do best. If you're a robotics guy, don't worry about the tractor. If you're a vision person, don't worry about the robotic arm. And then everybody's going to need some patience. We're going to iterate and evolve. That's where we're going to start, these top three. Okay, here's where we start. And you say, hey, Mike, that's a blank page. And that's not what was intended here. We're going to start with defining the platform interfaces. And then we're going to build out the rest. These are all the elements to make a common modular architecture survive. But that's not sufficient unto itself. We have to have the specialty crops industry participate just as heavily in identifying who the producers are, the crop agronomy, the crop harvest methods and tactics. All of this becomes a database of information that the modular architecture has to have easy access to. And then let's not forget, we have the harvest solution provider. People, and this is where a lot of things fall apart. You have to have a channel to the market. You have to have service and support. You have to have competition. You have to have these things to have a viable, long-term, sustainable industry. Okay. All right, that's the end state vision for what we're going to put together, the little blue boxes where we're going to start. Fortunately, after hearing this morning's presentations and knowing that a lot of this we're going to strive for off the shelf, we can hopefully rapidly fill out lots of this without dramatic effort. All right, let's talk about the elements of a harvest machine. Virtually every harvest machine in the world boils down to 4 elements. And I put a bunch of harvest machines on here, and I know it's skewed towards the big guys, the corns and the wheats and the soys, but everybody should recognize a color of machine so no one in the audience is offended. The reality is they all involve 4 different things. Working left to right, zone 1, you have to put the harvest somewhere. The blue in the one over, the zone 2, is the power plant. Could be a platform that you buy, it could be a tractor, it could be something, but it's where the operator will typically sit, and it's where all the efforts of the harvest machine are coordinated. The next is the harvest implement. This is after you've got it off the ground, what do you do with it? You thresh it sometimes, you move it to the back, you do something with it, and then the last place is the specialty header. The specialty header, it would be unique many times per crop. Specialty headers in specialty crops right now are human beings. They are the first cutter. They're the interface with the earth. They're the interface with the tree. They're the interface with the vine. Okay. This picture had a lot more complexity in it, but I was told, boil it down, get it a little simpler. When we talk about the interfaces, there are 6 interfaces between on a harvester. The first one is between the power plant or the platform and the back end where the crop is being stored. These interfaces could involve things like PTOs, hydraulics, high-speed electronics, all sorts of sensors. We are going to endeavor to define those in a way that can sustain a path towards full automation. Second one is between looking forward on the vehicle, because a lot of specialty crops are cut ahead of the vehicle. We're going to do the same thing. It'll look a lot the same. PTO power. If you're a startup worried about hydraulic pressures and flow rates, we want to provide standards and stuff where you can just trust. You don't have to become an expert in that. Moving forward, between the implement and the specialty header, this is where the fun is really going to start. Because we've heard a lot about tech. We've heard a lot about vision systems, machine learning, artificial intelligence, sensors, LiDARs, radars, ultrasonic. We want to define the interfaces to a very high-end processing unit so that the robotics guy does not have to develop the processing unit. They can trust, they can host their controls code with an ARM and make things happen. Fourth interface is between the cutter head and the field. And this is really where all the money is made or lost, because it's one of the most difficult things to do. It's the end effectors picking apples, it's the blades cutting lettuce, it's whatever it turns out to be. This is where the real challenges lie at this point in time. We want the best and brightest to focus there. Next interface is between this entire system and the cloud. We're going to move some data. We're going to process data offline. We're going to process data online. But overall, it has to be defined, and that is nearly commoditized at this point in time. But a lot of people don't realize this. They feel that they have to redevelop that entire subsystem. And then the last one is between where the storage tank is or the accumulator is and how you offload to the vehicles that will be actually taking the crop, either in packages or whatever, to the processing plant or storage facility. Okay. So we've looked at this a lot more organically. We have identified several areas that very few companies, if any, can actually do this entire run. We want to make it easier on people so they don't have to become experts in compliance, which involves all sorts of expertise, regulation, building safety, that sort of thing. Food safety. We have a lot of people who can develop robotic arms but don't have a clue about food safety. We don't want them to have to become food safety experts. We want to get food safety boiled down to some real basic things so that the easy stuff we get right. Food safety has a lot of complexity to it, but we want to get the easy stuff right. Precision ag. This is where Trimble plays and a lot of other people, but I can say that for guidance, GNSS, controls, this is nearly commoditized. And there's some really good equipment out there. You shouldn't have to worry about building a GPS receiver to run a robotics arm. By the way, in precision ag, one of the key elements is that you georeference everything. You have to know where stuff is. You have to know where the permanent crops are. You have to know where the rows are. You have to know where the vines are. And it will come down to, as one of the earlier speakers says, you got to know where each orange or apple is. But it all starts with having a common reference system. It's widely available today in very high quality and reasonably priced. Robotics, sensors, and artificial intelligence, machine learning, huge, tons of startups, but this is a herding the cats effort because there are brilliant, brilliant people out there that are doing the same thing over and over again. We have to be able to leverage stuff so we can build upon versus just build more of. Software and hardware infrastructure, this will be a key element. Define an operating system, define a set of interfaces, APIs, that everybody can use and trust. so that you can actually focus on what you do best. And this is the most underlooked one, a channel, a dealer network, and I put in California because we're in California now, but this is a worldwide issue. You can't expect a farmer to buy something that they have no good faith estimate can be supported, that can have their people trained on, can be repaired in a short amount of time. These logistics are huge. They must be addressed. Field testing and ground test truthing capabilities and the Ag Channel training service and support, very underlooked in the industry. Okay, and this will be my last slide. Just to summarize where we're going to go with this, use the four-quadrant module, the four-zone module of a harvester, use the 80-10-10 rule, basically stay broad in the definitions, don't be overly prescriptive, make it crop independent at this point in time because these interfaces are crop independent. It may not appear so, but they actually are. Focus on the critical things that we're missing, identify the gaps. No intellectual property. Walt talked about this, and I'll give a good example. You build the best camera system in the world. Maybe it's a stereo camera that does everything in the world. I don't care how you made it work. I want to know how to speak to it. I want to know how to get that data off of it. It's in your best interest to tell us that. If offloading data out of your camera is intellectually property protected, your camera's going nowhere. Or it had better be for free and the best thing on the market, and people will then go with you. But there are plenty of cameras out there. Let's get the interfaces down. Let's identify cameras that are sustainable in the fields and have a supply chain and support behind them. So no need for intellectual property to be disclosed. We'll use subject matter experts, as Walt described, to get this off the ground. We're going to use the philosophy, it's much easier to edit than create, and after this very short-term effort, we are going to open it up to a wider audience and then a wider audience. We cannot have chaos to start this off. We have to start with a nugget, and we'll build upon that nugget. And then we need a secure and sustainable data repository, data environment. More than ever, we don't want to get into a situation where the data is not available because we've made it too hard to access. We don't want to make it so easy that it becomes a poor man's Wikipedia. And because we need quality data entered into the system, and we need it sufficiently protected. And then the deliverable for this first stage is an interface document and candidates for Sentinel projects to go reduce the risk of the long-term technology path. Thank you.
Thank you, Mike. Really helpful presentation. Hopefully that puts a few details behind all the discussions to date. As mentioned, we're in the process of recruiting the subject matter experts now. Hope to have that completed in the next several weeks. Then the work begins, and Tech Stack 1.0 is underway. So at this point, we want to bring in Claudia Ressler from Microsoft. She's got a great perspective on this. Obviously might be a little bit more software focused, and as we mentioned, that is where Tech Stack 2.0 goes in earnest, and Claudia's got some thoughts. So if you're ready, Claudia, welcome, and thanks for joining us.
Thank you so much. Thank you, Walt. Thanks to the Western Growers Association for allowing me to join you remotely today. It's a truly an exciting event. I was able to listen in so far. Now, a lot of the speakers have talked about the multitude of issues that we're facing in the industry, from the average age of farmers that is growing, the cost of labor, the pure fact of availability of labor. And we even learned that in some cases it's not even economic viable any longer to grow certain fruits or vegetables in certain regions. When I joined the Western Growers Association conversation, I think around 2019, all of a sudden those challenges become real. I mean, they became faces for me. I met farmers that were ready to rip out their trees so they can introduce automation on their farms. I even met growers that built their own robots. I learned that, some growers pay workers higher just to ensure they take their time and fruits don't get harmed when harvested. And I learned how incredibly difficult it is to keep seasonal workers healthy in times of COVID, not so much on the farm, but in the temporary housing they live and they spend their time after work. So for me, there's no question that there is a need for technology that's enabling humans. And there's also no question that this technology needs to be comparable or better when it comes to work quality, the speed, and also security standards when you compare it to humans. So we heard a little bit about this already, but this technology, this robot has a brain that can act on challenges you're giving it. It needs to be able to see. We also see robots that smell and that hear today already. It needs to understand contextual information like we humans would understand contextual information. So for example, a grape might look different if there's a wildfire around. So robots need to understand to process this information in a different way. They might need to understand human voice commands, sorry. And like Mike said, they need to be able to move, they need to be able to orient and hopefully not kill people or plants while they do it. We talk about autonomous systems. We talked a lot about actuators that grab and move. And really what's important here, this is not just hardware. This is about imitating human motion. For example, like picking an apple. You need to be able to precision spray in milliseconds while something is running over a farm. And then those systems also need to be able to be remotely managed. You need to be able to deploy updates. So you cannot fly in people to run updates. And you might need to manage a fleet of robotics. And now I haven't even talked about data. And we heard some of this today. There's data that needs to be processed on the device or on the robot, what we call on the edge. There is data that needs to be provided into the supply chain. And then there's data you want to analyze post-harvest to improve sort of practices, kind of building a learning system of information. So all of this technology is managed by software. And, I spend a good amount of my time gladly with AgTech companies, like some of the ones we met today. And it's amazing to see the level of innovation those organizations are bringing to the industry. Some of the greatest have presented or will present today, and I have an incredible respect. But I also see that other speakers said this before, there's a lot of reinvention of the wheel, or even this like not invented here syndrome. And you see that even when when you travel from one continent to another. And some of the startups are building this entire tech stack from scratch with 1 or 2 people or 1 to 10 people and staff with various level of background in technology. So one might be a super expert for AI, but is the same person an expert in security. So now let me say that I just don't think, and I just repeat what others have said, I don't think there is time for reinventing the wheel. This is even more true when you see what's coming down the line. We're facing a wave of innovation that's coming on the robotics side, from things like cobots that are collaborative robots that work alongside with humans. We see improved senses and advanced vision. We heard about images and image repositories, but we're heading into using synthetic images to train AI models, which might make some of this even unnecessary. And then we see more and more of those robots being managed out of the cloud, which then enables collective learning and enables a higher level of human-robot interaction from a remote perspective. And then there's a whole wave of innovation coming around security and safety, because those systems, if they're open to the cloud, open up a risk of hazard. So if you want to move at the speed of light, you just simply cannot build everything from scratch. And I'd like to encourage the tech providers that are in the house today or listening in to really think about those modular systems. So you saw Mike Denchinger speaking about the common modular platform. That's really what we also consider as a platform as a service, a building block that allows organizations to build those solutions on top of it. From a Microsoft perspective, we have super heavy investments in IoT. I mean, just to give you this perspective, in IoT alone, there's a $5 billion investment in 10 years to improve everything that's related to the Internet of Things and things like digital twins. We have, I think, 5,000 people working alone on the artificial intelligence technology that includes everything from vision recognition, language translation, video recognition, and other things. So for this initiative specifically, we have building blocks like some of you might have heard about FarmBeats as an agriculture platform that's enabling not only data collection from the farm, but also has those data standardization and is enabling analytics on top of this geospatial and temporal data that's collected. We have another team working on AirSim, which is an open source simulation platform for autonomous systems. We have something called Project MOAB that's focused on deep reinforcement learning for machine teaching, which again is very important to train robots on those reoccurring tasks and improving those. And then there's simple things like fleet management that may or may not play a role for an individual startup in that place. So Microsoft wants to support the initiative. We want to work together with the startups. I want to take the opportunity to give a shout out for our Microsoft for Startup program, which really also has this ambition to help young organizations or companies that need help, both on the financial side, which in our case would be then through things like cloud credits, but then also help to access the Microsoft ecosystem and give access to internal and partner resources that help both in the development, but then also in the area of co-sell. Now, you're in best hands with the Western Growers Association and their members, but there is an opportunity for us working together with those organizations to help them bring their products to the market. We want to bring those building blocks that I was just talking about to the table and then really help organizations to build their solutions on top of it. I'd like to encourage the startups that are listening in today to really think about those partnerships. I know in my conversations, there's trust involved, and we need to build this trust in those partnerships. I want to encourage the investors that are in the room today to encourage the startups to build this trust working with strong partners, because I truly agree and believe what my previous speaker said, that this is a joint effort, and we won't succeed without one another. So for that, I'm just incredibly excited to be part of this initiative and to see how this started off today. And I congratulate the Western Growers Association for a great kickoff so far. Thank you.
Claudia, thank you. I'm Dennis Donahue. I run Western Growers Innovation Center, and I'm Walt's sidekick on this project. And I think most of you know me, and I think I know most of you. You know, it would not be an AgTech event if there weren't panels, and so we happen to have a couple, and with a good group. And so I'm going to ask Candace Wilson with Green Venus to come up, and I think she's got a few sidekicks that are going to join her on stage. So I'll ask them to come up, and they're going to visit for about 30 minutes, though they are a very stimulating group, and if they end up going a little longer, that'll be okay. We're running a few minutes ahead. Following the end of this panel, we will take a break again for about 15 minutes. So I'll just tell you this before, in terms of the housekeeping, and you will still find coffee, lemonade, pastries, and cookies, and that sort of thing. So that'll be there. So it will be a 15-minute break right after this panel. And with that, Candace, you and your group are on.
Well, thank you, Dennis, and hello to everybody here in Tulare and around the world. I've been a part of this project for the last several years, and so I woke up this morning just feeling incredibly energized and excited for the day to finally be kicking this initiative off. And I've been so encouraged, as we've heard from all the different speakers, just because of the consistent messages that we've heard today, and hopefully that's as Catherine said, pretty comforting to all of us that we agree and it's time to move agriculture forward. So I want to say thank you so much to Western Growers' commitment and to all the people who have come alongside Western Growers and are leading this initiative forward. As Dennis said, my name is Candace Wilson, and I'm the Vice President of Business Development at Green Venus. Green Venus is an ag startup who has developed a platform, a non-GMO speed breeding platform that's enabled by the Nobel Prize-winning CRISPR technology. And we are really excited about the possibilities of this technology, specifically in changing the plant architecture and enabling robotics to do what they need to do to help with the harvest. So I'm going to let each one of these panelists introduce themselves and provide a little bit of background about who they are and what their organization is contributing to these efforts. Go ahead.
Well, good morning, or afternoon, I guess it is. I'm still asleep. That lunch just put me over the edge. Anyway, my name's Ted Batkin. I'm actually a retired person. I've actually retired about 4 times, it seems, in the last 7 or 8 years. But I spent most of my career managing commodity board research programs, first in the vegetable crop arena for tomatoes, potatoes, celery, melons, and started the carrots and pepper programs. And then from there I went to the citrus research program. For 20 years I was the president of the California Citrus Research Board and then chairman of the National Citrus Research Committee. And our purpose for being on here today was the activities that we did in the citrus program in developing a robotic harvester for citrus. And it was quite an interesting process in the fact that we were able to put together all of the components with the exception of one. And we had the platforms and all of the algorithms and everything to map the tree, but the end effector was the deciding factor. And you've heard this from a number of the speakers before, the importance of that. So that's one of the things I'll be focusing on and talking about as we go forward with this initiative, is to get that last bit to get over the hill, if you would, and make something that's effective.
Well, good afternoon. My name's Neil Callis. I'm with Turlock Fruit Company. A little bit about my background. I had a 20-year career as a project manager, systems engineer, as a NASA contractor, before my father-in-law invited me to join the family farming business. And, you know, my interest and my role in this automation and mechanization initiative has been to try to be the loudest voice about some of the hardest crops that are, some of the crops are going to be the hardest to automate and mechanize. In my case, is melons and asparagus. And, you know, in my prior background, I had a lot of experience with open source software systems. And once we had that fateful meeting, I think it was in 2019 in Orange County, where one of the venture capitalists in the room turned to me and said, how many cartons of melons are shipped in a year? You know, whatever it was, say 18 million or something. And you, okay, well, what's the problem space that you're trying to solve by mechanizing the harvest? Well, $1 to $2 a carton. And there were 5 or 6 VCs in the room. They all looked at me and said, we're not interested. There's not enough opportunity to develop a solution to that particular problem. So that led directly into the conversation of the value of a modular platform to solve not just asparagus or melons or other difficult crops, but to build something that can be used across all the platforms. So that's my interest, and I'm just super excited about what's happening here. So.
Good afternoon. My name is Catherine Van Weerthuizen. I'm from Oxbow International, and we're a member of the Pulgar Oxbow Group. So we're a niche market ag manufacturer. We play in a lot of the specialty markets. Like Mike said, some of the specialty crops have been mechanized, and those are the areas that we play today. So, you know, blueberries is a big business for us. We do grapes for wine. We do veg from the perspective of a lot of processed veg. And I did notice one of the harvesters you had up there, Mike, was a pea combine, so I appreciated the shout out to the pea combine. And we design and develop and manufacture, and then we also do support some of our equipment around the globe. And you know, I met Dennis a little over a year ago, and we were talking about, you know, this group had come together in 2019, and the question was, well, who's going to build some of this stuff? And you know, it may or may not be us, but I think that everyone's alluded to the fact that these are complicated, challenging projects, and like Neil just said, the single industries can't do it alone. We look at crops and we try to help find solutions, but we really need to have this larger understanding. How can we do stuff that's more common, that's more modular? How can we not invent every single subsystem? And so we're here to participate and to lend some of our expertise in the, you know, not the huge thousands of unit manufacturing, but in smaller scale, but you know, medium scale manufacturing, and what that looks like, and what that looks like for field support, what that looks like for ground truthing, you know, getting out in the field, and those inevitable problems when the field and the crop just don't quite cooperate. So that's who I am.
Awesome. Thanks, guys. We do have a panelist who is absent from here today due to COVID. Her name is Jenny Maloney, and she is leading the North America Strategic Accounts team from Bayer Crop Science. And I think that it's important to recognize Bayer's commitment to breeding right now, and there have been several people who have brought up plant genetics. And it is, while it's not nearly as glamorous as an AI model or the very interesting work that lots of the robotics companies are doing, plant breeding is going to be a very, very important piece of bringing this whole vision together. And I always like to point out the fact that it also can be the limiting factor. We're talking about speed here. And the genetics companies have been placing bets on where they think the future of agriculture is going. But those plant breeders today need to know what the robotics need. What does the machinery need to look like? Because it's going to take 5 to 20 years for them to change the architecture of the plants and the trees that we're talking about. So Bayer's crop science and the work that they're doing with plant breeding, you know, I'm going to try to speak on behalf of Jenny a few times today, but plant breeding will be a really important piece of this. So I would like now to just open up the conversation to the panelists and talk a little bit about what are your perspectives on what the approach has been in the last 10 years, and why is it time for us to turn the page? Anybody?
Well, unaccustomed as I am to just jumping in with both feet and trying to get them both inside my mouth at the same time, and I seem to be successful at that. But over the past 10 years, I've had the opportunity to take a real close look at what is going on in the robotic development era. First with the citrus board when we were developing the citrus harvester, and then I spent 2 years as a consultant to a company called the Brain Corporation. And I want to mention this because it was a fascinating drill in frustration that was funded by Qualcomm as a part of their think tank group in San Diego. And the objective of the Brain Corporation was to get a robot that would train itself. It would actually think like a human brain, and then it would learn by looking at what it was doing and training itself. And the reason I mention this as part of this discussion is because the president of the company's focus was on strawberries. And he just knew that he could build a robotic harvester for strawberries that would go out and go down the row and teach itself how to find and pick and correct the strawberries. Well, unfortunately, it was one of those adventures that was more cerebral and less hands-on and applicable. And after spending 2 years and a whole lot of Qualcomm's money, about $15 million, they found out that they could not teach a robot how to pick a strawberry. And the purpose of mentioning this and bringing it up is that it shows that there have been just a wide range of attempts at trying to get these robots to work. And what has been lacking in the process is a coalition of multiple disciplines working as a team to develop something, as opposed to a whole bunch of verticals. And we talk about silos, and the people working in silos, that has to end. Or that prediction of getting 2% in 10 years and 3% in 20 years will be fact. So to get around that, we have to be a team. There has to be this effort that WGA has started, and believe me, we have been talking about this for years, because I get to be the old man on the panel, and that's only because I am, is that, USDA 12 years ago put together a robotics team to try and do this, and it didn't work. And other institutions have tried to do it individually, and they don't work. It's this collaborative effort that we're putting together now with this initiative that will get us over the hump and make it work. That's just my opinion from an old man's perspective.
Well, let me jump on that too, because I think it's worth highlighting, and again, this is putting on my grower hat. Our feeling, those of us in the cantaloupe and melon industries, those of us, the few remaining California asparagus farmers, we see about a 10-year glide slope until labor simply isn't available. I've been with Turlock Fruit Company nearly a decade, and I haven't seen anybody younger than me joining the company in the field or in the packing shed. So there is a real sense of urgency here to meet that time frame that you've talked about. And, to sort of put another slant on this too, if you think about a great book that was published in 2005, The Long Emergency, and that's a book about peak oil and what happens when eventually it's no longer economical to extract oil for use as a fossil fuel. And leaving aside the climate change discussion, just the idea that at some point that could occur, there's a general sense among people who know and understand the issue that there will be some panacea, some magic savior, some silver bullet that will descend and save us all. It'll be hydrogen. It'll be electric cars. It'll be this. It'll be that. And it really is the intellectual realization that that's not going to happen. And so coming back to this effort, that was my realization. There wasn't going to be a company. Elon Musk is not going to save us, for example. He's not going to come solve this problem for us. And it really is this kind of a coalition and the difficult bottoms-up work that has to happen to build the tech stack, to enable the startups to solve that last mile, the end effector problem. That's why this, in my view, is just so critical.
Yeah, to jump on that, and Candace, you said, what's the last 10 years been like? It's a lot of people trying to be really good at all the things, right? I think Mike pointed that out too in his presentation. To think that we're all experts in everything from compliance to to the chain, the support chain. I mean, no one by themselves really can be. Even large manufacturers or large companies can't be experts in all the spaces. And when we each try to do it on our own, whether that's each try to do it on our own as a crop type or each try to do it on our own as, to all the different functions, we need to rely on each other and work together and say, all right, you're really good at robotics, I'm really good at metal, you're really good at AI, let's come together and build a stack and get farther down the road. Because going at it one by one, we're burning a lot of money and we're burning a lot of time.
And I think that's a really important, Catherine. The growers, and maybe Neil, you can speak to some of this perspective, but a lot of the struggle that I've heard as I've been engaging with growers throughout the industry is the amount of ag startups that show up on their doorstep, want to learn about their farming operations, and get their resources and access to their farms to do their own trialing. So, Neil, can you talk a little bit about the complexity of navigating all these ag startups that are wanting your attention?
Well, and that, I think it's important for companies like Turlock Fruit to make bandwidth available to support the startups. I will say my experience, it's not that it's complex, it's more that it becomes an exercise in I'm telling a story to them that disappoints them because their product is not going to work for us. Because they've come up with a concept and they want to ground truth it, but they've essentially got a sealed box and it either fits in that spot or it doesn't. And for us, I mean, especially during the early days of drones, going back 5 or 6 years when the drone thing was a big deal and the imagery, the near infrared and imagery was a big deal, I would always come back and I'd sit down with my father-in-law, who's a master, melon farmer, and what can we do with this, Steve? And Steve's like, you tell me. We don't have the precision irrigation or fertigation systems to address a corner of a field that's weak 6 weeks into the growing process. It's just you shoot the whole field or you don't. There's no way to act on the data. So that's been a learning process though for the growers as well. As I think the startups that have come to visit us.
Sure, I think that just further supports the need for all of us to be working together and having those conversations. While you have the microphone, Neil is also a board member at the Western Growers Association. So I would like to just hear some of your perspectives, Neil, the enthusiasm, maybe talk about the board's excitement and energy around this initiative.
Well, and I would say that, look, I can't speak for the whole board, but I can speak for myself as a board member. There's a lot of excitement about what's happening here. There's, of course, trepidation about the amount of resources it may take to get this going. So, again, just as I take it upon myself to be the loudest asparagus advocate in the room, within the board, I'm trying to be the loudest advocate for what we're trying to do with the Innovation Center and with this common tech stack. Because the board, you have representatives there from the biggest players in the biggest industries to one of the last asparagus farmers farming 300 acres of asparagus, and so you have a range of potential beneficial outcomes, and they're not all going to affect all the people, all the businesses represented, all the industries represented on the board the same. But having said that, I know the board is anxious to see this thing get going and anxious to see some output and see the tech stack and work and understand that connection between the common modular platform and how the startups can leverage it down the road.
Thank you. Catherine, I would love to hear a little bit more about the significance of the standardization.
Yeah, it's a great question. I think it goes to the point, right, of 400 different crops in the state of California, and all of these crops needing slightly different or slightly specialized parts. But it's like, does everything need to be special? I know that it was mentioned earlier, right? Farmers and the farming community is passionately individualistic, and that plays out into how people farm and how they grow things. But doing 100 different ways to harvest 400 different crops is we're not going to get there. We're not going to get to scale. We're not going to get to something that can be supported. Someone brought it up. I can't remember who, but there's going to be new training of employees, right, for more complex in-field or in-plant equipment, and so there needs to be standardization there. And so you think about how many common components are on the shelves, this 80% idea. If we can pull in more common components, then we can specialize if and where we need to. That really opens up some economies of scale. It opens up easier support down the road because equipment needs support, and all these crops are perishable. And so, the more commonality, so whether that's from a systems perspective, from off-the-shelf components, from even common chassis that can carry different types of end effectors or different types of arms that can interact with crops differently. That's how we're going to get there. I don't see a way globally or domestically in California how you can get there with all of these crops if we have to do it all uniquely.
Yep. Ted, I have a question for you too. So you've been such a great voice on our committee, just about what you think it's going to take to really carry this baton all the way to the finish line. Do you have any insights or recommendations on how we're going to be successful?
Well, thank you, and I do, and it goes back to something that I learned very early on in my life, and I have a sign that I carry with me from office to office that says simply, "Make something happen today." And what has to be guarded against is hours and hours and hours of happy talk, because happy talk doesn't make anything happen. It just makes everybody feel good. And to get this process and move this initiative across the finish line, I'm sorry for that metaphor, but it's really what we're trying to do. We have to guard against falling into the trap of happy talk and saying, oh, everything's wonderful, and we did this and we did that and everything. But if you don't make something happen to move that forward, it won't happen. And so this initiative is getting away from happy talk to making something happen today, which will get us to the end result.
I think that's amazing advice. And I remember, Dennis, 2 years ago when we were at Harris Ranch, we concluded the meeting with, let's go. Let's just go. So here we are kicking off this initiative, and hopefully we're all pretty excited about just getting started. I would like to just conclude with hearing more from each one of the panelists. We're probably winding down on time, but talk to us about why you and your organizations have remained committed to this initiative, and maybe what do you think success looks like? So at the 5-year mark and the 10-year mark, how do you envision the farm and the industry? Anybody?
Well, I can jump in. I mean, the reason that Turlock Fruit remains involved and will remain committed, where we farm in western Fresno County, it's out in the middle of nowhere. It's already hard to get people to work there. And we farm between 4,000 and 5,000 acres. If we don't have people or machines or something to harvest cantaloupes, honeydews, melons, and asparagus, well, I guess we can put in almonds or pistachios. The problem is every other farmer up and down I-5 is going to do the same thing. And you look at the price of those two commodities and how they've fallen in the last 8 or 9 years, it won't work. We're not going to be able to abandon specialty crops in favor of something easier like almonds. So it's do or die time over a 10-year period from my point of view. So we'll do whatever we can to make this work. But what does success look like? So, to me, success looks like some form of a harvester that can get melons off the ground so I can get them into a packing shed. Because I know the technology exists, that once I've got those melons in the shed, we can go a long way towards automating and mechanizing that piece of the business. But that's the hardest part, is getting them off the ground and into a box or a bin so we can get them to market. But that's success.
Catherine?
Yeah, we remain committed, and we're excited to be a part of the group. And I think it's the collaboration between all kinds of different players in the industry. And you alluded to it at the beginning, Candace, but that was something that I brought up early on. Is it does come down to plants too. Some of the plants that we're growing today that are that we've bred or we've used because they're great for hand harvest is not going to necessarily be the plants that we need to be growing in the future. And so I think, we have to have this open conversation between growers and industry and what's coming down the pipe. I mean, you look at what Washington has done with, trellising and new varietals, and it does start there. And if we're whoever the collective we, right, if we're developing equipment for the old style of crops, we need to all make some adjustments. So we're involved in this space to understand, we love specialty agriculture. And so we're here to see where we fit and how we can help and what that is, if that's expertise or if that's understanding compliance or specialty crops or, whatever it is. We're invested and we're excited about the future because we think specialty crops should be grown here, and we want to be a part of what that looks like in the future. So what does the future look like? I don't know. I think it's people and machines somehow involved in the next 5 to 10 years. I don't personally know that it's going to be fully autonomous, because I look at a lot of the crops that have been mechanized, right? There's still people and equipment together. So I think it's going to be newer plants and genetics that help support maybe different planting styles, maybe stuff we haven't quite thought of with spacings or densities that are conducive to mechanized harvest to reduce the hard labor out in the field.
Right on. Thank you. Ted?
Well, my vision is this. In 5 years, or maybe it's 7 years, we have an oxbow machine going through with arms on it with a whoosh suction tube, picking size 88 oranges on demand, and all the rest of the oranges are left on the tree because the packing house that is going to has an order for 20 carloads of 88 size oranges. And that's the panacea. And that is highly achievable with all of the tools that we have in the toolbox. We just have to assemble them so that they're in one package that accomplishes that goal. That's the panacea for the citrus industry.
And a perfect segue to my dream. So, when you talk about plant breeding, and I have my Green Venus hat back on right now, my hope is that from a genetics perspective and a plant breeding perspective, that we all embrace the power of the Nobel Prize winning technology. CRISPR gene editing is an amazing tool that will allow us to bring innovation to market in a much more precise way than standard conventional breeding. And we're going to be able to do it a heck of a lot faster. So when you think about all the tools that a breeder has in their toolbox, CRISPR is one very valuable tool that's going to allow us to move the needle. And if there are no other questions or comments from the panelists, I'm going to wrap up by just reiterating what we've heard so many times today, and that is that we are all stronger together. So I'm really excited about everyone putting their hand in the huddle. I hope that we don't get discouraged by the unforeseen bumps that we are sure to see in the road, but rather let's stay motivated, stay focused on the roadmap, and in 10 years, the industry will be reaping the benefits of all of our collaboration. Thank you.
So in the best spirit of just do it, would you like to do the growers panel now because we're running a little bit ahead and then take a break, or would you like to take the break as scheduled? How many for a break? We're going to keep moving then. All right. I'm going to be the moderator for the next panel, and we're going to bring up Don Cameron and Drew Kettleson and Josh Ruiz. I think I see you out there. So we're going to visit with some of Western Growers' finest and chat a bit more about this issue. And Candace and group, thanks very much. Well done. All right, gentlemen, we're gonna jump right in. First thing I'd like each of you to do, and Josh, I'll start with you, is just self introductions and from your perspective, the importance of this problem and challenge. Josh?
Sure.
You should be.
There we go.
There you are.
My name is Josh Ruiz. I am the Vice President of Ag Operations for Church Brothers in Salinas. We are a fully integrated vegetable shipper. We have our own harvest company, farming company, spray company, sales, marketing, the whole 9 yards. And so we are California, Arizona, and Mexico doing all the leafy veg that you're all familiar with, of course. So that's who I am. Thanks, Drew. I don't know if anybody of you heard that. But so anyways, we are Church Brothers. I'm Josh, and we are fresh vegetable harvesting. And so we are really interested in this group and what's been going on. And the reason we're involved is because we believe it's going to take a group coming together and actually doing something and working together to get this off the ground. So we're excited to be here and appreciate you guys having us.
Good. Thank you, Josh. Don?
Good afternoon. I'm Don Cameron, General Manager and Vice President of Terra Nova Ranch, located southwest of Fresno. We grow a real wide variety of crops, specialty crops, and then about 25 crops in all, trees, vines, and quite a bit of vegetable and seed crops. And I've been pushing hard on this for quite some time, because without the innovation, without the replacement for some of the labor that we definitely need on farm, we really don't have a good future. We're seeing the declines in just getting labor to do the manual harvest that we have right now, and with all the regulations that we deal with as farmers in California, we look at the possible labor savings and the efficiencies that a program like this can bring to really all growers. I look at the rest of the U.S. We've got 90 million acres of corn, we've got 80 million acres of soybeans, and in California we have 27 million acres of farmland and 400 different crops that we farm here, and the economics have just not been there for one individual commodity to really do the automation that we need. So that's why I feel this is important, to have a stable common platform for all of these minor commodities that are extremely important to the economy and all of us here in California.
Good. All right, Drew.
I am Drew Kettleson with HMC Farms, and we are a grower, packer, shipper of table grapes, peaches, plums, and nectarines. And we are here and participating in this initiative. For us, it's really do or die. With the products that we produce, it's about 70% of our cost of every box is labor. So for us, harvest labor is hugely important, but there's other steps along the way that we are looking to tackle as well. So for us, this labor initiative and automation initiative it's imperative, and it's going to allow us to stay in business, because without something to help us get this done with fewer people and rising costs, we won't be able to exist.
Okay, great, thank you. one of the things I'd like each of you to do, because having spent some time with you over any number of years, each of you have kind of approached the issue kind of differently. Josh, one of the things I'd like you to chat a little bit about is, you know, and just I've always been intrigued, as I know others have been, when they hear the story about how you approached the broccoli challenge, you know, what you did and how that worked, and I think it really does speak to, you know, you've got to work with other elements of the industry to make something happen. So talk a little bit about that, and then how you've kind of tackled this issue to date, and then Don and Drew, just to tip you off, that same question will be coming your way. So.
Yeah, so I've been working on broccoli specifically for well over 10 years now, and you know, I'm going to sidetrack here a little bit. Success, I've been sitting in the audience today, and people have been asking the question, what does success look like? And for me specifically, and for us at Church Brothers, success is not losing the ability to farm fresh vegetables, especially broccoli here in California. Right now, including us, there's a huge vacuum to Mexico, and that's because of labor, and we don't, it's too expensive, it's too complicated, there's too many regulations and things like that. So I just want to keep growing broccoli here. And because of that, I've been working on this project for, like I said, better part of 10 years. I learned a lot from traveling around the world and just looking and listening to other industries, as we're doing here. That's, again, part of the reason why I want to be a part of this group. There's so many different industries that are going to help us all. Even though I want broccoli, somebody else wants oranges, the common platform is going to allow us to get there quicker. And so I've done that over the years. And long story short, like the last panel was just talking about, I quickly realized that in order to automate my harvest of broccoli, I had to completely reconfigure how I farmed the broccoli. I had to open my mind to be willing to change every single aspect of what I do in order to make automation happen. I thought I could just start with creating a machine. I couldn't. At least I couldn't. My team and I couldn't. So we went and we found a new way to farm. We worked with Monsanto. I've been working with them for a better part of that 10 years on developing genetics that helped me fit the machine better. And so the last thing to come into play was the actual machine. So we changed the way we farm. We changed the genetics to fit us and the machine. And then we created our automatic harvesting machine. And so today, I can take a machine out into the field and cut my broccoli with it and take it into the shed and process it. And I can almost do it with very little hands touching it, or almost none. And it's because I went through the steps and was willing to change everything along the way. So that's, for me, you know, doing something. I was talking earlier with several of you. Doing something is what we need to do, and this group is doing something, and we're going to get it off the ground. I believe that, and that will inevitably lead to these other things too. So that's kind of what we did and how we got started.
Well, and I think that's an interesting point about you want to keep farming broccoli here, you know, and you think good old broccoli, it couldn't possibly go away, but I'm going to guess Neil, if he thinks back on asparagus, you know, this will be a true statement, only the fact may be false, of once upon a time we farmed about 60,000 acres of asparagus in California, and now we're down to 600. So, you know, and that's not the only example of something could leave. So, right. So to hear broccoli on that list, I think is kind of sobering. So Don, how have you taken a look at all this? You know, the word on the street when it comes to innovation, and if we need to go see somebody, he's going to look at things, is you. So you've been looking at and thinking about these things. How have you attacked the problem?
You're right. We talked earlier about the Silicon Valley invading the San Joaquin Valley. And over the years, we had a lot of people show up with a lot of creative ideas. And we definitely take a look at them and see if we do have a fit on farm. But what we found we would find somebody that had a good idea, but as you heard earlier, they don't want to change their way of doing things. I mean, we'll give them advice. We'll tell them, you know, if you make some tweaks here, this thing would be much more widely acceptable. And the ones that listened, the ones that changed, we worked with. We started working with several companies early on, and they actually made changes to their whole product. that actually fit a wide variety of growers, not just us, but we found that the ones that listened have been the ones that have been successful. And, you know, I look at a project like this, I believe we can really be creative and innovative and get a product. And that doesn't mean there won't be failures along the way. I think you learn probably your biggest lessons are from the failures you have. So I don't think that, you know, we're gonna have something be great. We start out, we get something that works fantastic on farm, but I think there's going to be a lot of tweaks. I watched the videos this morning of some of the products that are out there currently that they're marketing, and yeah, they're head and shoulders above what we have or haven't had. But when I see that, I think, my gosh, that thing's going to hit a mud hole, and that thing's going to be twisted like a pretzel, you know, on the first pass through my field. So I think there's got to be some practical on-farm learning, and just, you know, I look at what we're venturing to get into here as a really successful program. I think I love the 80-10-10 because I do believe that there are a lot of components out there that can be adaptable to what we're looking for. I think that we just have to find the right people, the right companies, and make the right connections, and maybe modify them, maybe bulletproof them, as we say in ag, to where they can survive.
Well, it sounds like you're a fan of one of my favorite themes of what has been kind of random in marketplace. We're going to step in and make it more intentional and focus, and that creates some opportunities for us. And at the end of the day, that's good for everyone, because the last time I checked, you all will probably be buying the product. So
we'll be there. Your
opinion matters. So, but the other thing I'm occasionally intrigued by is, you know, did you ever hear farmers are conservative and they don't like to change? I hear that a lot, and then I run into guys like Drew, and you know, in terms of how you've approached this, you know, obviously you're looking at technology, but you've gotten those boots pretty dirty with your work in the orchards and redesigning trellises and all that good stuff. So talk a little bit about how you've approached this problem also, that it's not just technology.
Sure. So the way we look at it with our old systems in our stone fruit was you weren't able to adapt new technology to the old way of growing our fruit. So what we've done is we've been so far pretty successful is adapting our orchards for coming technology. A lot of it is, you know, for stone fruit harvest, that technology isn't available yet, but we're hoping that when it does become available, we will be able to utilize that. We can't go through and having permanent crops, you can't tear out everything in your whole operation and then wait 4 years and then have an orchard that is available to be automatically harvested. So we're kind of being proactive in that sense, and we're getting a 2D structure planted. And along the way, as I mentioned before, it's not just the machine harvest that we need to achieve. We've removed ladders from our pruning. We are mechanically thinning, and we are harvesting on platforms, all which can't be done with our old growing systems. So in general, that's been one of our biggest successes, is modifying our growing systems for the oncoming technology advances that should be coming down the road.
Okay, sounds good. Josh, you know, we were chatting a little bit this morning, and you kind of shook your head as we kind of just did a quick run through the globe and who's working on what and what are they doing. And you made the observation about everyone else. What?
Yeah, I made the observation that a lot of other areas or regions, part of other countries, are much further ahead than we are in the fresh vegetable world, specific to Salinas Valley and that cohort of people. I think it's been said many times already today, a lot of us, including myself, have a one-of-a-kind machine that we created in our garage, basically. And my machine, while it works, is parked right now today. And so that's not a good thing. And we all need to come together, like we're doing, to try to make this better, as these other groups and these other countries are. Yeah.
And I want to play with that before we move along. So, and without putting you on the spot, why is the machine parked?
The machine is parked because you know, I can think up a lot of things in my head, and I can scratch them down on paper, and I know what I want, just like these gentlemen do, and a lot of the people who have been up here today. But I can't make it happen. Me and my team of bandits have taken it as far as we can take it, and our shade tree mechanics can't take it any further. And a lot of you in the audience and maybe listening online have seen my machine. It needs to go that last mile to finish. We got it 90% of the way there. I just need help getting it over the finish line, and that's why it's parked. It's not parked because it doesn't work. It works, but it doesn't work perfectly.
So Don, kind of pick up on that a little bit. So you get a machine that works. That's all you need, right?
Yeah, I wish it were that easy.
Is there something else besides it works?
We need the support. We need the technical training. We have to really, you know, we talked about the plant type. We have to have the right circumstances coming in from all different directions. You know, we talk, when I look to our future, I see a different farm. I see plants that are designed for mechanical harvest. I think there's going to be some major changes. We're going to have to be more precise in what we do and how we, I mean, we can all put straight rows up in a field. That's great. I mean, I remember when we couldn't. But, you know, we've come a long way since then. And I think everything we're going to be doing in the future is just going to become more and more precise. And being precise is going to give you the ability to do the additional mechanical robotic harvesting. And I look at even at weeding. I mean, we've worked with robotic weeders on farm. Anything that we can do to cut down on labor is going to be beneficial to us and make us, it's going to really keep us competitive in the world. As I said, California is an expensive state to farm in.
Okay. Well, speaking of expense and cost, so, and you've obviously spent time on the ag ops side, and then I know you play a little bit on the tech side in terms of looking equipment. So it's parked, that last mile, expense and service matters. What's all involved in the adoption process, really? Because, you know, a lot of the focus is on, okay, here's the product, but what else has to happen?
So that's one thing that we have been haven't had to face really yet, but we're planning on facing is, like Neil mentioned, having the bandwidth. You have to create the bandwidth to adapt to these things. You can't just expect the technology to come in and it's hands off and it runs itself. The bandwidth is, you know, ownership time to analyze something, make sure it has an ROI. The bandwidth is having employees that, you know, what I would call the hands-on tech people in the field that are going to be managing these fleets. And the bandwidth and capacity to charge 1,000 batteries, to move around 1,000 different robots. It's more than just having the technology there. There's a lot of logistics and things you don't think about. It's tough to deal with. It's been kind of tough to deal with at a small scale with experiments, let alone, you know, bringing a whole entire fleet of something that adds new complexities to your business.
Okay. Josh, so one of the things you know, we've kind of teed up the question, well, what does success look like? And so, you know, and I think folks will want to hear that for your perspective. But to me, there's kind of a follow-up question. When do you define success, you achieve success, but what's going to make you feel comfortable with the success is real rather than, you know, it's kind of like a sports career. You could have a great rookie year, but you're worried about that sophomore jinx. When do you feel like, what will it look like when you get there, and what causes you to feel like I got there? I mean, is it multiple seasons? Just how do you define it, and what does it look like, and when do you go, okay, we're going to commit our operation to this?
Yeah, so I don't want to dramatize it too much, but really, truly, success in my mind is that we get to continue to farm here, because right now, from my perspective in the leafy green world, it's bleak. It doesn't look good. I don't see a bright future when it comes to being a fresh vegetable farmer in the Central Coast and being profitable, sustainable, if you will. So that really is a big part of success. But the other part of success for me with with respect to what we're doing here is just doing something. If this group can make the common platform, which I believe they can, and if we can get all that, the tech stack done, and we can have some of the big players involved, we can start moving the ball down the road. With me and my group of guys, we are big on just do something. Put something in the field, and I think somebody said it earlier, if it fails, who cares? If it falls down in the mud, who cares? Just pick it back up and we'll do something else. Just do something. So that's success. And then when do I feel comfortable? Like my machine today, we've got well over $1 million into it. If it was running every single day, I'd be, man, that's success and a long-term thing that's going to go. Then I'm super excited, because what we have today is great, and I can show everybody it, and it runs, like I said. But if it was running every day and just clicking down the road, I would be much more happy.
Okay, Don?
Yeah, I mean, I look at, when I look at the projects that are hopefully going to be coming from this, I look back at the canning tomato industry and how that all got started with mechanical harvesting. It was an idea. It was put together. The first machine was very simple, and it was a matter of how many people can you fit on that machine to sort the fruit, and it was much better than hand harvest. But as you see what's happened through time, we've got more efficient in the way it moves through a field now. We've got electronics. These things can pick 25, 30 tons in 15 minutes. And I look at this as the same process. Let's get something in the field, give growers a chance to find the problems, and growers will definitely tell you how to fix it and how to change it and how to tweak it if you get it in their hands. And I think that's the key. We have to get something out there. It may not be perfect, but let's get something going. Let's get something in the field and let the experts that run it show you what the problems are.
Okay. Don, thank you. Drew?
For me, success is probably just being able to stay in business and to be able to get 20 years down the road and give my kids the chance to continue in the same business. Success is being able to, like Josh said, farm specialty crops in California, to be able to just have those crops available. Maybe someday there won't be peaches available at all, except canned.
And that would be bad.
And that would be very bad.
That's right.
So, and another big metric of success is technology that works in the field that isn't parked in the yard, because I think we've all been burned by that, where you invest a lot of money and time and something doesn't work out, and you've got a big paperweight sitting in your yard. So that's another big success, is equipment that works and is functioning.
Good. Okay. Just any final thoughts? If not, we'll close. But any final comments? Did we miss anything? Once upon a time, I used to stutter from when I got off stage. Gee, I wish I had said. Any I wish I had said? Because this is YouTube, live streamed, preserved for time immemorial. So here's your chance for any last comments?
My only last comment is let's just make sure we do something. Let's get out in the field and let's do something. We have a great group of people here. We have a great start. We put a lot of people put a lot of time and energy into it. Let's just take that leap of faith and do something.
I like it. Good. Don, anything?
Yep. I think you've got the right team put together. You've got to access what's out there. I think there's fantastic technology. We just have to bring it home and put it together and get it out in the field, because without it, we're in trouble long term.
Okay. Thanks, Don. Drew, any final words?
Let's just share our ideas and move this thing on.
Sounds good. Good segue to let's take a 20-minute break. And while we've been busy all day, Australia and New Zealand have been sleeping. They're up now, so they'll be ready for us at about it's about 2:20 now. Let's call it 2:45. Be back. There's still refreshments, cookies, lemonade, coffee, etc., and a little networking and a chance to visit before we hear from our friends down under. So, gentlemen, thank you. Good words and a lot of experience on stage, and really a strong point there's something at stake here, so we need to get this done. So thanks, gentlemen. That was easy. Well done. Thanks, Drew. Thanks, Don. Thank you very much. Yeah.
At.
I see Steve's online.
All right. So thanks for heading back from the break, folks. Thanks for sticking on with us remotely, those of you on live stream. Our next presenter is David Inges. Hope I didn't butcher that name, David, from Rocco, joining us from New Zealand. And the next four presenters will all be from the New Zealand, Australia area, and three of them are startups, including David. So, David, let's see what you're up to down there with Rocco, if you're ready.
Thanks for that. Thanks, appreciate the opportunity today to meet the team. So, yep, David and the co-founder and CEO of Rocos. And am I sharing on my side, or have you got the presentation up on there?
We have the deck on our side. If you just indicate, let us know by sound when to move the slides, we're good.
Okay, sounds good. As mentioned, we're a New Zealand startup. We work in a range of sectors, including AgTech, and today it's really looking into the evolution of robotic operations and how it's not just a question of the robot selection and the capability of the robots, but going forward, how do you scale the robot operations? How do you manage them both in the field, but also from a centralized point? So I'm going to just cover off some of the ecosystem that's involved and where the industry is heading and the type of work that we're doing in that. Appreciate going to the next slide. Just a quick summary of the three areas we really focus on. We focus on connectivity of robots, and that's both connectivity of the robot to a centralized system, which is often run in the cloud. And that can be the robot back at head office, or it could be from the field. But the connectivity also includes connectivity with operators on a local connection where there is not cloud connectivity in that environment. And a lot of the work around that too includes very heavy investment in security protocols. Because once you've got robots connected into cloud infrastructure, it's ensuring that they're a protected asset. Secondly, it's around monitoring. So how you keep an eye on the actual work, the jobs that the robots are carrying out. And there's various interested parties from head office operators, making sure the jobs are doing the work that they're intended to do, but also down to the mechatronics engineers being able to diagnose problems in the field from that remote location. And the third area is really around the concept of control. And control has two aspects. One is designing the jobs for the robots to do and coordinating the fleet of various types of robots live in the field. And secondly, it's around intervention. So if a robot has a problem in the field, a remote operator can take teleoperated control of that robot and get it out of that situation when required. If we go to the next slide. In terms of the ecosystem, probably best just to press the button a few times here. You really have, firstly, the robotic providers that are providing the capability of the physical automation in the field. And on the hardware side for the robotics includes the autonomy stack. So the work that the robot can autonomously carry out, which could be mowing, fertilizing, weeding, picking, all of those various aspects. And of course, you may have more than one robot and more than one robot type in that orchestration. So increasingly, we're starting to work with organizations that have multiple robot types, and those robots have to actually interact in those types of scenarios. On top of that, it's about platforms like ours, which is around scaling. So really, how do you connect all of those robots carrying out the jobs into a centralized system and have one central view of all of the work that's taking place? And we have views which are based on what we call personas for the people interested in managing those robots. You might have a view which is on a ruggedized tablet in the field connecting directly to the robot. You might have an enterprise view, which is all of the robots in all of the farms that, in the whole country that you're actually operating in. And the types of capabilities in the robotics operations system you're interested in is things like you store things like the infrastructure data. So if you have fruit environments, you may have GPS coordinates for posts. from which you can build things like missions, which can be sent to the robot. So effectively, you capture digital twin information about the environments, the GPS data, and that in turn allows you to do things like designing the work that the robots need to do. It includes things like fleet control, so sending those missions down to the robots and the coordination between them, mission management, which is individual robot mission design and pushing that mission effectively down to the robot. And also in reverse, it's collecting data off of the robots. And this needs to work both live, so if you have live connectivity, but also in a cached format. So when the robots collect data in the field, if they later on are then brought back to internet coverage, it can then synchronize that data. And that, for example, might be for a lab in the field type of scenario, or simply diagnostics data on how well those robots are performing. You also have IoT providers, which is quite a different set of technology. Generally, the IoT devices don't get updates to their missions. It might be a weather station. It's collecting a generic set of data, which is continuously pushed up to an IoT system. And then, of course, the business intelligence system is trying to gather the data from things like the robotic operations platform and the IoT system in order to give higher order optimization. You might be looking at farm health, you might be looking at moisture mapping, applying machine learning to make better decisions for the work that you're doing. If we go to the next slide, just shows really an example of this ecosystem. So firstly, you've got the robot provider. In this case, you might have a ClearPath robot. It may have a set of sensors on it. It has a set of autonomy in terms of being able to be told at a GPS location where to go to. But ultimately, something has to tell that robot all the different waypoints and actually design the path plan for that robot, tell the sensors when to capture what type of data. And there might be multiple sensors, multiple camera types, LiDAR systems, moisture sensors, all of those types of things could be on the device. So the robotic operations platform is intended to tell that robot where to go and what to do. And that can be done at scale. It can also pre-capture that mission, and it can give it to any new type of robot. So we might use a ClearPath robot today, and we might introduce a different robot next year, but the same mission is actually sent to the robot, and we translate that mission into the language that that robot speaks. So it avoids vendor lock-in for the farmers, and they can actually choose a range of robots as the evolution of the robots take place, plus the fact that we can communicate with very different types of robots at the same time. Your IoT stack might be something like Microsoft IoT connected to the weather station, and then your business intelligence system might be something like a farm beat. So that's just an example of what an ecosystem could look like with an integrated system. We go to the next slide. This is just an example of what a view might look like. This is just showing the Bay of Plenty in New Zealand. You may have some kiwi fruit orchards. You may be collecting some sensor data from having the lab in the field in those environments. In the system, you can see the robots, you can see the health of the robots, you can see if they're currently connected, what jobs have been scheduled. You may have the assets in terms of the orchards, the sizes, the GPS information is stored in the centralized system, which means it's very easy for an in-field operator or a remote operator to design a specific mission that needs to be carried out. That could be pre-sent to the robot, so somebody could literally deliver the robot, they could roll off the truck and immediately execute its mission, or if the robot actually lives in that environment, it could wake up, execute the mission, and go back to a docking station automatically. And then, of course, you're tracking the information that's coming off these environments. And in systems like this, it's all about being very, very highly configurable. It's easy to integrate the data with third-party systems, and it's easy to change the visualizations of managing the various type of crop that you have. If we go to the next slide, this is just a representation of, you might have that ruggedized device. It's not necessary to have cloud connectivity all the time for the robots. You may need a local connection. The same application can be used remotely, whereas when you've lost connectivity from the cloud, it can be used locally to connect directly with the robot. You can see the mission that's been organized, you can edit the mission and actually have that robot carry out. Plus you can get that diagnostic data back. And this is important that that mission, if it's edited by the person in the field based on a change of environment or an inaccurate development of the mission, that can be synchronized so that next time that same action has to be taken, it's now optimized and goes from there. If we hit the next slide, the kind of areas that we do a lot of work in is a question around where should we start in the environment. it's really, we look at organizations and what parts of the operation can actually be automated. And there's many areas that are growing. And next, it's about really identifying the robots that are capable of doing that work. And of course, there's also capturing data. So capturing satellite imagery, photogrammetry imagery, capturing GPS information, which becomes the heart of the ability to design these missions. And then it's about selecting a wide range of robots to carry out the various activity, and the system can then coordinate those robots from that central system. So I hope that gives people a quick overview of really, where the scaling in robotics is heading, and the types of systems that you're likely to be implementing, over the next years. Thanks a lot.
David, thank you. That is a great overview. And as you might guess, I really love to see the ClearPath, Microsoft FarmBeats, and IoT. That's exactly the approach we've been advocating for all day. So great to see you using some standard components and some modular architecture to build that out faster. So congrats on ROCUS. And next up, we've got Nikki Malloy joining us from Callahan Innovation. Nikki, we've got your slides up, and welcome when you're ready.
I know Steve's online, as he hasn't got slides. Can we move to him, if at all possible?
Oh, certainly. Steve Saunders.
Yeah, that'd be great.
Welcome from Robotics Plus. Yes, so no slides on this one, but Steve, welcome. We're glad you could make it, and you have the floor.
Thanks, Walt, and thank you, Walt and Dennis, for the opportunity to talk and be part of this initiative that Western Growers is launching. I think it's absolutely critical, particularly from startup companies and early stage companies like ourselves, to be able to have those centralized places of collaboration. It's very key to be able to solve some of these really complex problems, and being able to link and have that support, but also, the vision to start to develop some of the tools that can help companies like ourselves sort of accelerate at pace. I'll just give a quick bit of background on RPL, and then I sort of just thought I'd like to talk about some of the models and the experiences we've been having in terms of getting having success of getting the technologies into the field, because I think there's a lot of areas of collaboration and different ways to approach how we can actually fast track some of these solutions to our broader problems. So RPL sort of was really came out of the backbone. I'm a 35 years experienced grower. I have significant investment in pack house operations and orchard management operations in kiwi fruit and apples, proprietary fruit varieties. And really a number of years ago, I started to look at how technology is going to play a role in my supply chain going forward. And that's where really the Robotics Plus started from. And it's where I went looking and found my co-founder, Dr. Alistair Scarf. And he did a PhD project, which we supported, and which really showed that we could automate kiwi fruit harvesting. And that video has been seen a lot around, and you can find it on roboticsplus.co.nz. And through that, Alistair sort of proved to me that when you've got the combination of growing supply chain, growing knowledge and that support around that and guidance around that, he was actually able to really articulate that technology and demonstrate it was possible. And from that point, we went on to really grow Robotics Plus, which was really started around 2015. In 2018, Yamaha Motorco Japan came on as an investor. We're a team of 12. We're now a team of 80. And 72% of those 80 people are really experts in their field. And we've developed a very multidisciplinary team across a number of areas, from mechatronics, mechanical, electrical, software control systems, AI, machine learning, data and vision systems. And it's really the need to bring all those disciplines together to really solve these complex problems. And I know a lot of early stage companies really struggle with smaller teams and not having all those disciplines to be able to bring it together to really make these actions work. We've commercialized a couple of products. Our first commercialized product, which we are exporting into the US, Australia, and into Europe, was our robotic apple packing solution. That's a combination of machine learning, robotics, automation, and a sophisticated vision system where we can stem and calyx orientate an apple. We can place it in a tray or a package at whatever angle you want to pack it with the best colour side apple up. And our whole focus across our robotics solutions is that avoided cost of labour. So this thing had to make sense from an apple packhouse point of view, that this machine was replacing 1.5 to 2 people, and that ROI had to be right. We've just recently launched our new double packer, which is heading into, which is actually the first ones have just arrived in the US now. And that's now giving us speed capability of 300 fruit a minute across a double lane configuration, stem and calyx orientating with best colour side up. And in April, we'll be launching that apple packing technology to be doing stone fruit as well. So this technology goes across apples, then we move on to stone fruit, then we can move into avocado. So the technology is very agnostic about crop. It just needs small alterations about maybe how the in-feed feeds into the machine to do that. So what we've focused on there is really the core modular technology that allows us to develop on one crop that then very quickly make changes to deal with other crops. So we can create a level of scale and sensibility in using the same core modules of technology, which becomes a lot more efficient and cost effective. Our second technology that's commercial is robotic log scaling, which is a bit interesting. People say, what are you doing log scaling for? But in New Zealand, forestry is actually part of our sort of primary sector, so we consider it in our AgTech portfolio. That was a really great model where we actually had a customer with a real pain point. They came to us and said, we've got people climbing over trucks doing measurements of logs to look at what the millable timber is for the Japanese agricultural standard measurement. And so they funded that R&D of that project up front. We agreed on the terms that they fund the R&D, but then we retain the IP and the commercialization aspect. We agreed what those terms were. And we also had a conversation about, by removing your labour, we're actually your new labour, and how would you consider a sort of royalty type model around, we'll build you the machines, we'll agree on a manufacturing margin, but then we get a royalty for every tonne of logs we scan. And they agreed to that. We delivered that prototype into their shed within 12 months. Within 16 months, we're deploying commercial machines. We're now just over 50% of all logs exported out in New Zealand run through our technology. And that's a really nice model for us because we're really engaged with the customer. We're reinvesting back into the next piece of technology we're developing, which is taking a fixed robotic scaling solution to a mobile robotic scaling solution. And we're now looking at that technology being deployed into Asia and the likes of China. The big win on that model was really that coming together, really defining the problem, both parties having skin in the game and really determining and agreeing to what the output is going to be at the other end and how we're both going to have a win-win from a return on investment perspective. And, you know, that relationship's very, very strong, and we have a technology roadmap now that we're just rolling out one product at a time. And it's allowed us to concentrate and focus a very core development team to continue to do that. The third area that we're really focused on is unmanned ground vehicles. You can see the one behind me there, which is an autonomous mowing solution targeted into the likes of turf farms and parks and reserves. Again, we as Robotics Plus, we really adopt a partnership model. So we have the autonomous platform. There's a need for automating mowing. So we look to partner with one of the best mowing companies in the world that already have 50% of the mowing market in a particular field, and it's adopting their mowing technology onto our autonomous platform. What that allows us to do is these people have the sales and service teams in the field. They have the mowing technology and the grower relationships. We just really provide the automating it and making it simple. So again, we like to look at everything we do is really looking at finding end users and partnerships that really enable this action to happen. We're also doing projects with Yamaha USA around autonomous vineyard sprayer. Again, we came through, we built a fully autonomous vineyard sprayer in 9 months from zero design to actually trialing in market. And I think that leads me into, the opportunity in New Zealand. We're counter-seasonal. We were developing the unmanned vineyard sprayer for Yamaha when COVID hit, and rather than actually shipping the machine up to test in Napa Valley, the COVID restrictions of our team and being able to come together, the opportunity was we were able just to take that technology and test it in vineyards in New Zealand and be able to video and do a lot of work and perfect the technology, and now we'll be shipping that up to the US in September. So again, that counter-seasonal opportunity around New Zealand and that being able to test it at 2 different seasons. So we're testing it here through the summer and to harvest, and then we do fine-tune adjustments, and then we can ship it to the US ready for the US start of the season post-winter. And my last sort of area that I think is really important is the way Robotics Plus has approached its model and growing a team of 80 and actually getting a number of solutions out into the industry has really been around the co-funding model. It's been finding people that are actually really do have the pain point, and they're paying some of the R&D money, we're putting in money, and then we have a unique ecosystem in New Zealand where we can really leverage a lot of support from government, from whether it's Callaghan, who's going to talk shortly, or New Zealand Trade and Enterprise. And there's a number of large government science research funds that happen here. So we're able to leverage these partnerships really, really well. As long as there's a seen benefit back to New Zealand, which could be creating tech and export market, or actually helping solve some of the New Zealand growing systems, but then looking globally to actually create the scale to make it sensible. So a good example of that at the moment it would be the asparagus industry, which we know has a real challenge globally. And it's no different in New Zealand. New Zealand faces the same labour challenges as the US, as Australia, as Europe. So we have those same challenges. So we've had we funded some work with the university to look at some concepts around harvesting asparagus. It actually came up to Salinas in 2019 and did a bit of trial work on an asparagus farm in Las Banas, and then we brought it back to New Zealand. We've taken that alliteration on a bit further, but that work we did with the university had given asparagus growers some confidence in New Zealand to look to move forward with that technology. The government has now come forward and said, well, we're prepared to fund 40% of the development of a fully commercial asparagus harvester. I had the discussion with them around the fact that there's not a lot of scale in New Zealand. So for a company like us to target a New Zealand market, which might sell 50 machines, makes no sense from a scalability point of view. So we've been talking with the government about actually what if we went out and made this a global play, and we got asparagus growers from different countries around the world, with the same problem, and would the government still put 40% funding into the project if it had co-funding from both New Zealand and international growers? And they're very open to that model. So we're now actually working through that process. So what we're really starting to do is say, let's bring the global asparagus growers together. Let's talk about systemizing what is the growing system, agreeing on what is the platform actually got to perform. So this technology can be applied to everyone globally, as opposed to having 10 different variants, because everyone wants to grow things differently and do things differently. And so that's got really great traction. And so when you look at that, it's a $5 million New Zealand, 5 million NZD project. The government is funding 40% of that. Robotics Plus puts in $1 million, and we're actually only asking for $2 million from New Zealand growers and global growers to actually come together and have a 4-year collaboration to commercialise asparagus harvesting. So these models are working better and better, and it's also enabling us to put project teams across, but then also to translate the technologies across the different disciplines that we have or the different projects we're doing to really solve these problems a lot faster. So I just really wanted to sort of share some of the experience of how, you know, from a sort of 2015 to now, you know, we've grown a team to 80, we've got multiple projects, real customer engagement, commercial products going to market. And it's just really thinking about how do we do this more collaboratively and collectively? How do we think smarter from a global perspective? New Zealand grows most crops that grow in America. So there's this counter-seasonal opportunity, this collaborative opportunity. And there's government and other funding that can be attracted around these plays, and that's why we're very happy and very supportive of the Western Growers Initiative. We think it's that collaborative thinking and how you bring things together that's going to get us there a lot faster and a lot quicker. So I'll leave it at that. Thank you very much.
Oh, it's great, Steve. Thank you. That's a lot of great technology. And it's almost as if you were eavesdropping on our panel earlier, which I know you weren't. Neil Callis and others would certainly love a conversation about that asparagus machine. So we will make sure that continues. That's all good. Well done. Next up, Nikki, you were on earlier. I'm guessing you're still on and ready?
Yes, yeah,
Perfect.
I am.
You have the floor.
Thanks, Walt. And thanks to our two companies, Rokos and Robotics Plus, for presenting some of New Zealand's capability. And Steve, you've stolen half my presentation already, but great that I can reiterate some of the great work that Steve's been doing. Thanks also to Western Growers for this opportunity. New Zealand is very supportive of the work Western Growers is doing to bring this global initiative together around automating harvesting. We really value the partnership with Western Growers and also acknowledge the work of our industry partner, AgTech New Zealand, of which I know Peter Wren Hilton is on the line. And they've been working, and we've been working alongside them going back over 5 years. And this has led to the signing of a MOU between AgTech New Zealand and Western Growers in August 2018. New Zealand has been working closely with Western Growers and with delegations from New Zealand to Salinas and the wider California area to meet growers, understand the challenges and connect New Zealand's capability with US problems. And thanks to Dennis, who's been a great connector for some of the work we've been doing and connecting New Zealand and Western Growers together. To really understand those challenges. I would definitely like to echo the voice of earlier speakers and the need to accelerate the pace of work, and also we need to move to more collaborative ways to work together in the space and solve this global harvesting challenge. The industries, tech innovators, growers, researchers, and countries cannot work in isolation on this. And I think, you know, this has been echoed right throughout the session today. COVID-19 has had significant impacts on New Zealand's workforce, and despite New Zealand being in a very privileged position of having no COVID cases in our community, our ongoing border restrictions have meant that industries are very reliant on this migrant labour, that have been very reliant on migrant labour, and that is resulting in our shortages. So we haven't got access to the usual international backpackers. We have been able to allow Pacific workers to come in, but certainly less than we've ever had before. And certainly we're in our summer season here. Our apple harvest season is just getting underway, and we're already hearing reports of over only 70% of our apples likely to be picked in some regions. So we need to solve these issues along with Western growers and many of the other countries that are also in the same challenging position. I am coming in behind our two technology companies and really as part of the program of work that Callaghan Innovation, who I work for, and they are New Zealand's government innovation agency, and along with our other partner agencies, really, and enablers, we're looking to build a support a New Zealand global transformation program in AgTech. What I'm looking to do sort of through this presentation is really provide an overview of the work in place that will help support global initiatives like the one that Western Growers are presenting today, and hope to do that through just the range of support that will be on offer from New Zealand to really support the acceleration in this space. Next slide, please. The AgTech Industry Transformation Plan is a plan that has been launched, and really our vision is to become a globally competitive AgTech ecosystem, providing ingenious value-adding companies meaningful jobs and solving New Zealand and the world's sustainability problems. So it is New Zealand AgTech that's not only good for New Zealand, that is also good for the world. To do this, we've got 6 work streams in place that are looking really at how we accelerate this and really transform our industry. And one of the first one is really around globalization, and that's really helping our businesses reach global scale. We know we can't scale, as Steve indicated, our companies from just focusing on New Zealand alone, and it needs to be well connected to a globally scaling partnership program. Commercialization, and if you talk with any companies in this sort of startup robotics and automation space, commercialization is super hard. So part of what Callaghan Innovation is supporting is really around accelerating commercialization from New Zealand to the world, and how can we help our companies do that faster and more efficiently. And again, you know, these type of partnerships and global initiatives is really part of that acceleration program. Investments, we all know that we can't have great startup companies without good investment, so that's really strongly working. And I know Finisterre were presenting, and they're certainly one of our partners around investment, but looking at how we can attract more investment to scale and help our companies grow. Data interoperability and regulations, that this is something we're looking at in New Zealand, and I know it's been mentioned a few times throughout the day, but as a global industry and with all the technology, how are we going to ensure that the data standards and regulations are all connected and aligned? And skills and workforce, of course, none of us can grow these, both the technology companies and support our horticulture industry without having really strong skills and workforce support. And for New Zealand, it's really around ensuring that the government is aligned and can provide the best support. We're really the enablers of this. This is an industry-led program, and we're looking at ensuring that the government provides the best support for this type of growth. There are 3 high-impact projects, and it's really the one that we're focusing on today is the Horticulture Robotics Catalyst, and I'll go through and quickly talk about that. And this, just really to reiterate, this is an industry-led transformation plan, but the key partners in this are across government organisations such as Callaghan, NZTE and others, and really with our industry partner AgTech NZ. Next slide. So just to give you an overview on the Hort Robotics Catalyst. Next slide. The purpose of a catalyst, I guess catalyst is causing something to happen or change, and we all know that really we're all here about creating that, catalysing that change, doing that together. the ambition is for New Zealand to be a global leader in horticulture robotics. That's really our something. And the purpose is around connecting, collaborating and aligning our industry and positioning horticulture technology outcomes, both for New Zealand that can be taken globally. It does fit, it is our high impact project, and there's certainly great support both from industry and government towards that. Next slide. If we look at the ecosystem and part of any good plan, and I know Western growers are also working towards this, but is really ensuring that we have a really closely connected ecosystem. And in New Zealand, we're really lucky. We're small. It's 2 degrees of separation. But it still requires a lot of work to connect everyone together. So it is connecting our horticulture technology innovators to the problems. So that's both the problems of our local New Zealand horticulture companies, but also to those global scaling opportunities and working with growers offshore. Our industry groups, our investors and funders, having that government support and really connecting that researchers and academia to everything. So when you look at the sort of the overall map and you sort of throw a whole lot of logos on a page, it doesn't really represent the connectivity. And for New Zealand to really succeed, we need to take advantage of our small connected ecosystem. These are not individuals and not individual organisations. They are very connected in New Zealand, and we're very fortunate that we're able to do that very easily. Certainly, if, from what Robotics Plus talked about, and if you look at something like an example of the asparagus harvester project, that's really a great example of collaboration from across our universities, working really closely with a technology company to come up with a solution that's again aligned with Tender Tips was the original company in New Zealand, a grower that has got a problem and really working technology, research and growers working together on that solution. And the government coming together to supply that early stage support and funding, connections, advice that really helps our technology companies scale. New Zealand is a nation of innovators, and again, we've got companies like Tomra, which are actually an offshore company that has acquired 2 leading technology companies like Compact Sorting and BBC Technology. But what Tomra has done is actually retained their innovation centre and soft fruit packing and sorting in New Zealand, and that's really driving some of that key innovation, and also really helping us build out that tech stack and capability that sits in our sort of fruit packing, sorting, high value crops, with high value crops such as apples, kiwi fruit, berries, and soft fruit. So really, in terms of some of the world leading packing, sorting, and even with Robotics Plus and their apple sorters, there's leading capability that sits in New Zealand with our innovators, tech companies, and a lot of the capability that sits around that. We are we may be small on a global scale, but we definitely punch way above our weight. And I would describe in New Zealand every single orchard and farm as a test bed of innovation, and constantly blown away by some of the innovations that we are being seen from our growers. And certainly what we're doing in New Zealand is really showcasing some of that with our technology companies and researchers, and looking at how we scale that globally. And I'll talk a bit more about some of that work that's being done shortly. Next slide. In terms of the technology scope, and again, sort of aligning in with Western growers and the work that they're doing, and looking at the technology stack. Certainly robotics, automation, sensing, data analytics, AI, vision and imagery is really strongly aligned with what the Horticulture Robotics Catalyst is looking to build, grow, and continue to evolve. Next slide. And again, aligning with the crops that we're focusing in on, in and on the ground, on the vine and on the tree, and really within the scope of the catalyst, technology spanning from behind the orchard and through to the farm gate and market distribution. So again, really from pretty much seed and genetics right through to how do we distribute product is some of the capability that sits within the New Zealand ecosystem. Next slide. Just quickly, I won't go into too much details around this, but probably just focusing on some of the services that the Catalyst will be able to provide as part of a support for our technology companies as they look to work on in and around initiatives like what Western growers and the global problems around harvesting. Part of what the Catalyst will do is really be that industry connector, and already connecting into events and opportunities like Western growers have pulled together as a really important part of what we do. Certainly the project facilitation and support, and that's probably going to be one of the key things as this initiative grows, is really providing that key project facilitation point from New Zealand and the project leadership, and recognising that New Zealand is not coming with just single startups. We are coming with a fully integrated service, and so it's really how can we support our startups with the backing of researchers, the backing of our grower groups, and the backing of government, and really pulling that whole project facilitation piece together so that we can help accelerate some of the work offshore. It'll look to sort of provide support around commercialisation, IP, right through to funding and regulatory advice. So really, there's going to be there is and will continue to be a great amount of support that will be put in behind these projects and these global initiatives from New Zealand. Next slide. So the areas of impact really is around the technology, so it's facilitating, supporting technology commercialisation, growing the number of and size of our sector and our companies as we help them to scale and connect into global opportunities, developing our talent, that global impact, and really we are trying to make global impact, and that connectivity, connecting up both nationally and globally to accelerate commercialisation. Next slide. And just before I go into, we've got a short video, really part of the initiative that we're really looking to build is not just about technology. We have a strong partnership program approach from New Zealand, and we're already working really strongly in with the US and a number of areas, and one of those is around breeding cultivars for superior flavour, disease tolerance, and looking at how breeding helps with mechanical harvesting and processing. So this partnership approach is super valuable, and Steve touched on the value of that for what he's doing, but also recognising that New Zealand it's not just the technology. There's an amazing, we grow every crop in New Zealand, and some of the work that goes into our breeding, growing programs, right from seed through to genetics, breeding the best genetics for disease tolerance, firmness, flavour, and harvesting, as well as looking at right down to saplings and how they're grown to ensure they're productive. So right from small trees and how and the amount of innovation that's going in there, through to harvesting systems, how you grow a tree to ensure it's both productive, but also working towards what harvesting, what a orchard or farm of the future really would look like, and really innovating some new growing systems that will enable us to actually harvest more efficiently using some of these automated solutions. So if we just play that video, hopefully we can flick to that.
The Pacific Northwest area of the United States produces over 95% of the country's red raspberry crop for processing. However, traditional varieties of raspberry are coming under increasing disease and environmental pressures. In 1998, Plant and Food Research began working with the Northwest Plant Company, a nursery business in Washington State, in trialling new varieties from the New Zealand breeding program, and later on, in breeding new raspberry varieties specifically for the Pacific Northwest environment. This collaboration has resulted in the Wakefield raspberry that is now available to growers. Plant and Food Research has a long-established rubus breeding program, with proven success in developing new varieties of raspberries, blackberries and hybrid berries for the fresh and processed markets. Dr. Ron Beetson heads up the rubus breeding program at the Institute's Motueka site at the top of New Zealand's South Island.
The rubus breeding program is part of our thrust to have a berry fruit centre of excellence here in Motueka, and it's an integral part of the development of our plant breeding programs in the whole of the berry fruit area. So the rubus, I believe, has got a lot of potential for offshore development, and our science programs are geared towards delivering new cultivars that not only suitable for New Zealand but also could be suitable for other countries, cultivars that could be taken up to places like the Pacific Northwest of the United States.
The Wakefield raspberry has some key characteristics that make it suitable for the Pacific Northwest region, including resistance to raspberry bushy dwarf virus and high yields of firm fruit. Adam Enfield of Enfield Farms has found that the variety meets a lot of requirements for their processed raspberry business.
The key advantages of Wakefield, first of all, the flavor, it tastes excellent. The yield, it yields higher than the standard other varieties. The firmness is a really big deal. That firmness also, I think, helps with some mold resistance. It doesn't seem to rot as easily as the other varieties. The disease resistance, we have one field that's 5 years old, and it just looks like it's getting stronger, and the fruit quality is wonderful, and that's very exciting for us. It likes to be planted on a little bit heavier soil, which tells us it's a little bit root rot tolerant. It machines unbelievably well. There doesn't pick any green leaves, and the firmness of the fruit just rolls into the flat and looks beautiful.
The Wakefield raspberry is truly an exceptional variety for the Pacific Northwest processed raspberry industry. The plants are high yielding, machine harvest well, and are showing resistance to diseases such as bushy dwarf and root rot experienced by some other varieties. The fruit holds its shape well for IQF processing and has high levels of healthful compounds that consumers are beginning to demand.
Great. So I guess the reason for showing that video is really talking to the fully integrated approach that we're taking from New Zealand, from really looking at what the future crops would look like, and the fact that we're going to have to look at different ways of breeding and developing crops for this automated harvesting of the future. that the structures will probably need to change, and we're working hard to look at what those new structures are likely to be, and the amount of research that's going into that area. We're breeding for productivity, sustainability, and for the future harvesting options, so that when we look at our fully integrated approach, it is, you know, what are those breeds, what structures, and how will they be grown? What is the technology that's going to support it? And really, right from, you know, disease detection, crop estimation, and all the technologies that line up, and then ultimately, how will they be harvested? And some of those new and developing technologies that will support that to ensure that we can have those crops grown for a lot easier options in terms of harvesting. Last slide, please. Oh, we're on the last one. So, so really, just it's a great opportunity to be able to talk to you all today. If we look at what the NZ offer is and how we work, it is really a partnership program that we're looking to develop between New Zealand and the world. The access and that to our sort of fully connected New Zealand hort tech ecosystem, and that's you know, right down from our growers and how you can grow and use your technology to harvest, right through to what our technologies companies are providing, and that ecosystem of support with our researchers and strong government support. Cross-functional and agile project teams, that's what we have to offer, focused on impact and speed to market. And I certainly think that Steve has presented a great example of the work that he's done on being able to really accelerate access, you know, a problem from what he's done around the log scaling. And certainly how that's been supported by some of the government funding, the partnerships that he's been able to build, and a great example of how that can be done at speed. Access to innovative growers and off-season test beds to accelerate commercialisation, and that's a really what we've found with particularly in the harvesting area. And in the research area is that we offer that northern southern hemisphere testing environment. One of the challenges that really slows down innovation in this area is the fact it is seasonal. You've got one opportunity of a year to do all your research and innovation. If we can, the world can look at how to speed that up, it would be ensuring that, you know, you're working on 2 seasons in 1 year and using that northern southern hemisphere opportunity. And certainly, if you look at New Zealand, we grow just about every crop in New Zealand. And so certainly there's no shortage of access to crops and willing participants in terms of people and growers that would be keen to collaborate and help be those testers. We have a vertically integrated approach from genetics to the consumers, and a globally scalable built through strong international connections, and really appreciate the opportunity Western Growers have given for us to present today, and certainly encourage anyone who's looking to work with New Zealand, collaborate, connect, to get in contact. We'd be more than happy to talk about how we can do that through some of the initiatives that we've got in place. Thanks.
Okay. Thank you, Nikki. That's great. We appreciate the presentations from the startups and from you at Callahan. And our final presenter today will be Hunter from Ripe Robotics. Hunter, if you are on and ready,
thanks for that. Well,
you have the floor.
I'm here. Can you? Beautiful. Thanks a lot. Thanks for having us, everyone. My name's Hunter. I'm from Ripe Robotics. We're working on on machines to automate fruit harvesting. So we sort of came at this from with fresh eyes when we started this project about 1.5 years ago, having come from engineering rather than from agriculture. And when we're looking at the problems, we sort of realized that if you have a machine going through, like able to drive and navigate through orchards and able to assess fruit on a tree, and reach into any part of a tree, you're 90% of the way to solving multiple problems on these orchards. It's a small jump then to optimize it to pick fruit and pick different varieties of tree fruit, and also in the longer term to do thinning and pruning and precision spraying, and also to gather data while you're doing all of that. So if you can start with a base machine that can be optimized and upgraded in these different ways, then it should be possible to do multiple things and do them in a way that's actually even better than if you were just doing one task, because you can integrate the data from across the season, and you can learn things from picking different varieties. So far, we've built a prototype to do this. This is Clive. You can put Clive next to an orange or an apple tree, and it will assess the fruit on the tree, assess if it's ripe and able to be picked, and find the best angle to pick it from, and then it'll move in and attempt to harvest it. You can see it here, it's picking some of the fruit. It's also missing a lot, and it's running a little bit more slowly than it should. But it's a proof of concept that sort of shows that we are able to harvest the fruit under ideal conditions. And now we're working on improving that and getting it to a commercial level, a level where it's running reliably and fast enough that it would make sense to scale and expand. So to that end, this is our commercial robot, Eve. We designed it after doing the tests on Clive, and it's an iteration of that design. So one of the key things here is that with a machine that you're trying to get to do multiple things, it's very important that it's modular and upgradable, which I think lots of other people have touched on here. It should be possible to unbolt entire components of the machine in the field and replace them. So you can change the end effector to do different types of fruit and different tasks, or you can change parts of it as you come up with better ways of doing things. You don't want to be stuck with an obsolete machine if the technology gets better over a period of only a couple of years. So this design, Eve, can do everything that a human picker needs to do. It can assess fruit on the tree and pick it and transport it into a normal fruit bin with a bin filler, and then put the bins down and swap them in the field for an empty bin. And this is what Eve looks like today. It's actually what Eve looked like 2 or 3 weeks ago. The other part of doing this is that if you're having an upgradable machine that needs to do multiple, or that can do multiple tasks, you need to have the infrastructure there to actually support it. You need to be able to upgrade it and have the people there to upgrade it, and people to look after it in the field, rather than trying to interface with many different growers. It makes more sense that one person knows everything about the machine and can look after the machine and move it to whichever farm needs to be using it at that time. So we set up facilities like this. This is our facility in Shepton, where I am at the moment. We have technicians in the facility. They build the machine on site in the region where it's going to be used, and then they look after it in the field. They do all the maintenance, refueling, monitoring over the internet, and moving it to where it's needed. So that's all done locally by the people. And so building a machine that's very simple to do that and can be assembled on site is very important here. And so we use to enable that, we use a simple design and lots of off-the-shelf modular components. With that in mind, it makes sense to make it as easy as possible for growers to use the system, because it's not because it's improving over time. It wouldn't make sense for growers to have to put down hundreds of thousands of dollars for a piece of equipment that might be just barely commercializable now, but in 5 years we're expecting it to be significantly better. So we charge by the bin, and we'll continue to charge by the bin into the future, and work alongside human pickers. So we start with, say, one machine with 20 or 30 humans on an orchard, and then we can scale up the number of machines at the time. And we do ask for upfront deposits for those for the service, so paying for the first 200 or 500 bins upfront, and that goes to help cover the capital cost of the machine, which the company is having. And so it's different to a normal deposit because we are spending it partially towards building the machine, but then it's secured against the machine itself. And then in the long term, obviously the machines are going through the orchard and hopefully going through the orchard all year round, different orchards all year round. So they're generating a lot of data, which can be later analyzed by other systems and presented back to the grower to say exactly how large the fruit was, where it was becoming ripe, if there was any stress in the trees with wilted leaves or smaller sort of cross-sectional area of branches. Anything else that's visible through the sensors, we should be able to later analyze the data and present that back to the growers, in addition to the simple data, which we'll obviously share for free. So we're working in Australia at the moment. We have 3 trial customers who've signed up for that same system, so they pay for the bins we harvest. And we're working towards getting to a point where we're picking fast enough and reliably enough that it would be worth scaling the technology. Yeah, that's great here in Shepton. And right now the machine is heavily monitored by a human. So we want to maintain the high quality the entire way through. So as we reduce that human monitoring and reduce the human control and make the machine more and more automated, at each step we make sure that it's maintaining it at least human quality picking, and hopefully higher than above human quality, as far as avoiding damage to trees and avoiding the bruising of fruit. So this was done by myself and my co-founder Leopold Lucas. We're just a small startup working on this. My background's in engineering, and I did all the engineering work behind Clive and Eve. And Leo's background is in strategy and law and sales, and he also does the front-end development for our analytics platform. And we've got a great group of advisors and support from some of the industry in Australia. What we need right now is we're raising funding to continue the commercialization of the machine, aiming in the next 18 months to demonstrate that it's commercially viable. So right now you can take it out into the field, but it will because it's not quite fast enough, it's not quite reliable enough yet to scale. It's still trials. It's costing us more to run than it makes in harvesting, and so we're trying to flip that over the next year or year and a half. We're also looking to secure agreements with growers. So we set up these facilities in each region, and we need to know which region is most interested in having us. So securing agreements ahead of setting up and investing in these facilities, whether we do it in New Zealand or in Washington State or in California, we'd sort of need to know ahead of time where the most interest is. From growers right now, if we're looking for people to sign up to our commercial trial waiting list. So we've got our trial partners here in Australia, but we'll be signing up other commercial groups to do small scale first trials and picking in 2022 and possibly even late 2021 with the seasons. But really a non-committal kind of thing, just showing us where the value is, where the interest is, and also showing that to the groups that we're currently trying to raise funding from. That's the other thing we'd love help from growers and grower groups from, is helping secure investment to keep this project going. Either through direct investment from growers would be fantastic, but also through help securing grants from industry groups and governments, and even just speaking to private investors and assuring them that this is actually an issue, and it does have a large problem that needs solving, and that there's support there and interest there from industry. So thanks for that. I was running through that quite quickly. So if we have any time, I'd love to take questions, or yeah, thanks for having me there.
Hunter, thank you, and thanks for helping close a terrific day. And just very, very quickly, I want to thank you for your time and for coming today. It's a big world, but we covered the AgTech centers of gravity around this issue in a few short hours, and I think there are a lot of common themes there. This day didn't happen by accident, and one of the things Walt and I, when we took a look at this, we thought it was important to really kind of convey what's going on throughout the world, and we wouldn't have been able to do that as well without freestyle events. So you folks did a terrific job, and we want to acknowledge that and thank you. And I am smart enough to know that say thank you, a few closing remarks should be reduced to thank you for joining us today. But a little housekeeping. If you liked lunch, there are leftovers, and they packed them up over there. And before you head out, just because we're kind of social and hospitable by nature, there's still something to drink. There are cookies, and there's salsa and chips. So, and Walt and I were just lamenting, boy, it'd be a shame to see that go to waste. So, however you, so if you could help us out with that, that would be great. But I do want to say on a very, very serious note, one of the things you heard was this has been a couple years in the making, but we felt it was important that it be ready, aim, fire. And the folks who were in the room in May 1st, 2019, they're all still here, and they were here on their own dime, their company's expenses. And so really just kind of a strong belief that this idea makes sense. And as you heard today, now we're going to begin to put process and resources and a lot of people behind it. So a lot to look forward. And Mr. Dentinger is here. We're going to be starting to talk to companies. We get to work next week. So as you heard the admonishment, let's make it happen. That's exactly what we're going to do. So thanks, everyone. And I'm sure this will fall into the category of to be continued and ongoing. Thanks, everyone.